Welcome to Imaticus Learning. In today's masterclass, we are thrilled to dive into deploying machine learning models. Guiding us through this session is Gaurav Sharma, a certified data science trainer who's mentored over 1,000 students and professionals in mastering the art and science of data. Gaurav will be sharing practical insights and strategies to help you seamlessly deploy machine learning models in real-world applications. So get ready to elevate your skills and bring your data projects to life.
All right. Thank you, Nitin, for your introduction. Okay, welcome you all to this masterclass. I hope I am audible. Okay, that's it. Thank you. All right, so I'll just give you a brief intro regarding what we are going to cover, what are the steps that we are going to follow in this masterclass. So as Nitin have already explained, what are the things that are we going to cover, but I'll let you know the complete pathway. Okay, so what we will do, we will start by creating a model. Actually, I have two separate models, so we will see how to deploy them. Okay, so first of all, we will create a normal ML model. Then we see how to get predictions from that particular model using a Flask API. Okay, so we will create a app.py file using a Flask API. Okay, after doing that particular part and getting our predictions using our Flask API, what we will do, we will containerize our Flask application. Okay, so we will containerize with the help of Docker. And why we are using Docker? Because you will see when we deploy our model with the help of Docker, and when we deploy our model without Docker, the level of complexities increases exponentially if we are not using Docker. So Docker really simplifies the whole deployment process, and it is kind of a standard practice that is used in various companies. Okay. And also Docker is also accepted in your AWS also, Azure also, and GCP also. Okay, so this skill is must-have skill if you want to switch to any cloud platform. All right. So after containerizing our model using Docker, what we will do, we will export a Docker image to Docker Hub. So Docker Hub is nothing but you can say a repository, an online repository where you can store your images. All right. So after exporting our image to Docker Hub, what we will do with the help of that exported image, we will deploy our model in GCP. Okay. And in this particular process, in between, what also we will do, we will test our model. When we create a Flask API, then we test our model, whether it is giving us output. When we containerized our model using Docker, then also we will test our model, whether with the help of Docker, it is giving us output in our local system only at that particular time. Now, when we export our image to Docker Hub, then with the help of this exported image, what we will do, we will deploy our Docker image into GCP. Now, when we deploy our Docker image in GCP, and after that also we will test whether we are able to get predictions with the help of GCP or not. Okay, so we will test our models on three different stages. First, when we are using it locally in using Flask API. Second, again locally with the help of Docker container. And third, when we deploy it at GCP. Okay, so this is the scenario that we are going various other platforms and various So what I'll do, I'll already, done all the code and, write all the configuration files like this. But what I'll do, I'll write it from scratch in front of you so that you can also have a experience key how to deploy your models, how to work, how to start a project from scratch. Okay. So what I'll do, I'll just create one more folder, and inside that folder, we will have all our files. So I'll just zoom it a little bit. Okay. And just create a new folder here. And I'll rename this particular folder GCP demo model. Okay. Like this. Okay. So this is our empty folder. Okay. So yes. So see what we are going to cover here. I'll just lay out my plan. Yes. Okay. Yes. So what we are going to cover here. So first of all, I guess every one of you is familiar with your linear regression project that you have covered in Emarticus. For example, in that particular project, you have one insurance data. And in that particular data, you have various columns, and your output column is to predict the insurance premium. Okay. I guess this particular data you all are familiar with. Okay. This is the same data that we have worked in our Hugging Face deployment class. Okay. Yes. Okay. So quite a common data set. Okay. All right. So what we are going to do. So suppose you have that particular data problem, and what you had done is you cleaned your data. Okay, you handle all the deficiencies and all the cleaning process in your data, and then what you will do, you will fit your model. Okay, you'll fit your model in a linear regression or whatever model that you had decided, and finally you are satisfied with its performance. Okay, now you are satisfied that okay, model is good, model is giving good prediction. Okay, model is giving good predictions. Okay, so we are at this particular position. Okay, so we have cleaned our data, we have tested various configurations, and now we have come to the conclusion that okay, this model is giving us good predictions, and we are okay with this model, and we are proceeding with deployment of this model. Okay, so we are at this particular position. So at this particular time, what we have covered in our last class, that we have exported this model, okay, into a joblib file or a pickle file. So suppose I have exported this particular model in a .joblib file. Okay. So I have serialized this model, and now I can export this particular model. So now I am having this .joblib file. Okay. Now, in our previous masterclass, what we had done, using this joblib file, we have created a UI. Okay. We have created a UI. In that particular UI, we have various input fields for our users to enter. And when user enter all the data in those fields, and when he or she may hit this submit button, what our application will do, our application take all this data to our model, and our model gives us your output column. And we displayed that particular information here. Okay, your insurance premium is this and this. Okay. Now that particular part that we have covered in our last class is suitable when you want to showcase your project. Okay. For example, you are a student and you want to showcase your work to a future employer. Okay. So that approach is quite good. But when you work in a company, as a data scientist, you hardly design any UIs. Okay. So instead of that, what you will do, you will create an API. Okay. You will create an API. So what does this API will do? This API will let anyone to interact with your model, okay, without a UI. Okay. So while creating an API, what you have to, let's say, uh, give or to state to other users. Okay. So there are two things that you want to get clear. Whoever is using your API is, what is your input format for your API. Okay. You have to give this to any user who want to use your API, in which format, in which input format your API will take request. Okay. So you have to hit a API with a request, and in return, API will give you some response. Okay. And then also you have to state that what is the format of your API's output. So these two things we have to give to a user who want to use our API. Okay. Now, you must say that what is the advantage of having an API? Why don't we create a user interface? So the advantage of having an API is that, so if you have this API, you can integrate this particular API in many different applications. Okay. You can use this particular API in a website. You can use this particular API in a mobile app, or anything that you want to integrate a functionality. Okay. So if you want to integrate your model functionality into a mobile app, if you want to integrate your model functionality in a website, okay, or anything, or in an application, you can use use this particular API to incorporate your models in all those modules. Okay. So that is the benefit of this particular API. So most of the time, when you make a model, okay, you make your model with respect to APIs, so that it can be integrable with a lot of other applications. Okay. Okay. So this is how we will proceed. So we will not make any UI in this masterclass. Instead of this, we will see this API way, how to create this API, and how to deploy these APIs in various formats. So I hope this part is clear, what we are going to cover. Okay, this API part. Okay. I'm just asking about whether the plan is clear to you guys or not, what we are going to cover. Okay, good. Very good. All right. So this is how we will do. Okay. Okay. So again, we will start. So, okay. So what I'll do, I'll just, so I'll just have my models in this particular folder. So I'll share all the code and all the files with you guys on Drive. Don't worry about that. Just concentrate on the code, that whatever I'm typing here. Okay. So all the study material will be shared to you. Don't worry about this. All right. So, okay. So I have already created this particular folder. In that particular folder, I have all the files. So now what I will do to deploy my model, I need these two files, insurance_joblib. So this is my main model. Okay. That is, giving me predictions. And this is a poly object, which, create polynomial features. Okay. So like this. So I'll need these two. Okay. And I'll also need this requirement.txt, and we will see what this requirement.txt file will do. Okay. So I'll just copy these three files from here. And again, I'll paste it here. Okay. So now we have three files. Okay. Insurance_joblib, poly object, and requirement.txt. All right. What will happen? Yes, now it is showing that. All right. So first thing that this thing we also have covered in our last masterclass, and now you'll see its importance. Okay. So what we will do now, our first step is to create virtual environment. Okay, to create virtual environment. And now you will see that when you deploy your model in a Google Cloud or a Docker, creating virtual environment is very, very important, because it solves a lot of your complexities. Okay, so we have already learned how to create this virtual environment in our last masterclass. Now again, I'll just explain it, how to create a virtual environment. Okay. All right. Okay. So yes, so Now I'll open this requirement.txt file. Okay, now okay, it is open. So this is a requirement.txt file. Okay. So as you can see that we have these libraries that are required to make our model run. So these libraries are NumPy, okay, because we are using some NumPy functions inside our app.py file. Then we have this joblib file, joblib library, then scikit-learn, okay, for our model. Joblib is to unpack our model, okay. Flask is to create a Flask API, and request is to handle request. Okay, this particular library is not required for deployment, but it is required to make get your predictions. Okay, so if you want to deploy, it is not necessary to include this particular request library, but to make things simpler, I just want to stay in a particular environment, so I have also included this particular library. Okay, request library. So these are the libraries that are needed by us to deploy our model. Okay. So how to create a virtual environment using these libraries? It is extremely simple. So first of all, what you have to do, you have to open command prompt in this particular folder. So there is a question of Kuldeep. We can avoid writing library versions. Yes, Kuldeep, you can avoid writing these library versions. But what is the benefit of writing library versions? Because suppose, again, you want to deploy your model after 6 months or 5 months. Okay. So now at that particular time, what can happen is that maybe NumPy version got changed. Okay. Maybe scikit-learn released a new version, and maybe your model is not compatible with that particular new version. So when you include specific versions to your requirement.txt, it will ensure that if you again recreate your model after 6 months, after 1 year, it will definitely going to run, because your model is made using only those library versions, and you are again using those versions only to recreate your model. Okay, to recreate your deployment environment. Okay, so it is a good practice to write library versions. Again, if you don't write library versions, it will work, but there is no surety that it will work in future also. Okay. All right. Okay, so let's start. Okay. So, all right. I guess why it is hanging. Don't know. All right. So to open a command prompt in your particular folder, what you have to do in your address bar, you just have to type CMD. Okay. So just write CMD and hit enter. So it automatically what it will do, it will open a command prompt in that particular folder. So you can see that in desktop, I have this GCP demo model, which this folder I have just created in front of yourself. Okay. So this command prompt is in this particular folder, GCP demo model. And these are the files in this particular folder. Now I want to create a virtual environment in this particular folder. Okay. Now how to create a virtual environment? It is extremely easy syntax. So your syntax is Python. I'll just zoom it a little bit so that you can see it more clearly. So Python -m, then venv. Okay, so venv, what this venv will do, it is your syntax for creating a virtual environment. Then space. Now you have to mention the name of your virtual environment. Okay, so now you can give any name to your virtual environment, but the standard practice is .venv. Okay, so what does this .venv will do? It will create a virtual environment with the name .venv. Okay, so I guess you have known what does this dot represent. So whenever if you put a dot in front of a folder, what this dot will do to a particular folder, it will make that particular folder hidden. Okay, so whenever you create a virtual environment like this, you will create a virtual environment folder, and that particular folder is hidden. Okay, so this is a standard syntax of creating virtual environment. Okay, in our previous class, we have also created the virtual environment using different names. Okay, but now in many documentations, in many codes, you will see this is the code for creating a standard virtual environment. So I'll just press hit enter. Okay, so as you can see that a new folder is created here with name .venv. Okay. So this is our virtual environment. Okay. So it will take just a little time to create this virtual environment, and then we will proceed. Okay. So now you can see that our virtual environment is created for this particular folder. Okay. Now we want to activate this virtual environment. So how to activate this virtual environment? The syntax is again pretty straightforward. So what you have to do in this virtual environment, okay, it is hanging a bit. So okay, let's see. So what you have to do, you have to go inside this virtual environment folder. Okay. Inside that particular virtual environment folder, you have to go to a scripts folder. And inside this scripts folder, you have one command, activate. So you have to hit that particular command. Okay. Inside this VNV folder, you have to go to this scripts folder, and inside that script folder, we have to run this activate command. So as I press enter here, .venv is our folder. Okay, just a minute. I'll type it one more time. I guess I didn't give space or something. VENV, then scripts, then activate. Okay. All right. Just let me close this and again open this CMD. Okay. And let me also close this. I don't know why it is hanging so much. And yes. GCP masterclass, GCP demo. This is your GCP demo folder. Again, I'll open this particular folder. Okay, backslash is the problem. Okay. Thank you, Kanchana. All right. But now I don't know why it is not opening here. All right. So what I'll do meanwhile, if it is loading, what I'll do, I'll share this particular drive link with you guys. So I'll just go to my drive. There's masterclass folder. Now I'll create a new folder here. In GCP masterclass. Okay. And in this GCP masterclass, I'll share these two folders with you. These two are two different models. Okay. And I'll make it shareable, and I'll share this link with you guys. Okay, virtual environment is also there, so it is taking time. Okay, I have to exclude that particular virtual environment. Okay, no issues. So yes, I'll share it in chat with everyone. Okay. So you can use this particular link to get all the material. Material is being uploaded, so it'll upload in some time. Okay. All right. Again, we will go. Yes, GCP demo model. Okay. So don't worry, we will use it using this CMD command. Okay. So we are actually in GCP demo model, and what we will do, we will use .venv is our virtual environment. Then we will have this slash, then scripts folder, and after this scripts folder, we will do activate. So when we do, now you can see that our virtual environment is being activated. Okay. So here you can see that we have a .venv like this. Okay. Now, what we have to do, and okay, instead of that, let me again deactivate it. Okay. I'll show it to you in VS Code. Okay. So what I'll do, I'll open my VS Code in this particular folder. So how to open VS Code in a particular folder? You have to type like this: code space dot. Okay. So when you do like this, VS Code got opened in this particular folder. Okay. So now you can see that we have all those files that are in our, what to say, in our folder. It is here. Okay. And now I'll open a new terminal here. Okay. So I'll open a new terminal here, and I'll just zoom it a little bit so you can also see it better. Okay. This is sufficient. So this is our terminal inside this particular VS Code. So now what I will do, I'll just activate my virtual environment. Okay. So this terminal is same thing that your CMD is now. It is same thing. Okay. Nothing special here. So to activate a virtual environment, we just have to do .venv. Then we have to go to scripts folder. And after this scripts folder, we have to do activate. So when I hit enter, now you can see that my virtual environment is being activated. Okay. How you know that your virtual environment is activated? Whatever name that you have given to your virtual environment is being displayed here at the start of your, address. Okay. So now it is saying that you are inside a virtual environment. Okay. All right. So next, what we will do, next, we will install all the dependencies in this particular virtual environment. So where we have stored all the dependencies inside our requirement.txt, these are all our dependencies. Okay. So how to install that? The syntax is standard: pip install, then space -r, and then the name of your file, requirements.txt. All right. And I hit enter. Now what it will do, whatever libraries that are mentioned in your requirement.txt got installed in your virtual environment. So now you can see that all the libraries that you have mentioned here are being installed in your virtual environment. Okay. So it will take some little time to install. Meanwhile, what else we can do? I don't know why this Explorer is not working. Okay, so meanwhile, all the files that are that we are going to use are here, so we don't have to worry. So next, what we will do, we will create our app.py file. So as you have already remembered in our last class, we have made this app.py file to make a Streamlit application file, and then we will create this particular Streamlit application. But now we will do we will create this app.py file little differently. Okay. So there is a question from Mohit, what is poly object? So Mohit, in the process of making this model, what we have done is that we have created some polynomial features. Okay. So this polynomial object is to say object that when you pass your data inside this polynomial object, it will create polynomial features of your data. I'll show you what it is what it is doing to our model. Okay. All right. So this is our app.py file. Now what I'll do, I'll just recreate this app.py file in front of you, and we will see how it is how it is performing, how it is doing your work. So okay, let's go to our again new VS Code here. So now you can see that all our libraries are installed and our virtual environment is good to go. So to see how we get predictions using Jupyter file, what I'll do, I'll just recreate one Jupyter file here. Okay. So new file, and I'll say this, rename this file is test.ipynb. So ipynb is nothing but your Jupyter notebook format. Okay. So this is our Jupyter notebook format. And now if I write any code here, it will ask me to install ipy kernel for this virtual environment. So I'll just write import pandas as pd, import joblib, import numpy as np. I guess we don't have pandas, so I'll just comment this out. Okay. Now if I run this, now it will ask me Python environment. Now I'll select this .venv that we have created. Now I'll select this particular environment. Now what it'll do, it'll install this ipy kernel. Okay, so it is telling me you require ipy kernel for this. Now I'll click on this install. Now it is installing. Okay, so what I'll just do here, I'll show you how to get predictions from these two polynomial objects and insurance joblib. Okay, so what we will do, first of all, we will load our objects. So model. So model is nothing but joblib.load. And now what I'll give its address. So copy relative path and paste it here. Okay. So this is your model. And now I run this poly object. So poly object is nothing but joblib.load. And here we'll give its address. Copy relative path. We paste it here. Okay. Just run this. Okay. Okay. First it will finish installing this, then okay. So suppose our model got loaded. So now what we have to do, so when we created our model, we have set some particular way which columns are required. For example, this is how you load your models. So I have loaded my models like this. And if you see that, this is how you will pass your data to your model. Okay, first you have to pass your age data, then BMI, then children, then smoker num. Okay, so smoker num is nothing but 0 if you are non-smoker and 1 if you are a smoker. Okay, so these are the columns that we needed to get a prediction. Okay, so in this particular format, what we will do, we will test our model whether it is giving us output or not. Okay, so again, I'll just copy this thing so that I will remember what is the order. Okay, so I'll just copy this and again go here. So this is our format. Okay, so now what I'll do, I'll again create an array. Okay, so I'll create a test data. Okay, so test data is nothing but again np.array. I'll just paste this np.array, and inside this np.array, for age, suppose yeah, I'll give data like this. Key age. I'll just copy this from here. And in age, suppose I'll give 25. Okay. BMI is 22.6, suppose. Then children are suppose 0 and smoker is suppose 0. So if I give something like this, okay, and then I'll pass all these variables inside this numpy array, and this is our test data. So I'll just show you what is the output of our test data. So if I run this, so you can see that this is our test data. Okay. Now what we have to do first, we have to pass this test data in through our polynomial object. So how to pass this particular test data in polynomial object? You note that above here we have loaded our polynomial object with the name of this poly object. Okay. So poly object dot transform. Okay. I guess all of you have used these standard scaler or simple imputer. So what you have to do in those particular transformers, you first on training data, you have to do fit underscore transform to fit your data and transform your data. And for test data, you simply need to do dot transform to transform your data. So this polynomial object is already trained on a particular data set. Now, all I have to do is to use just dot transform to transform my test data. So inside this dot transform, all I have to do is to pass my test data. So if I do this, so you can see that it has recreated these many columns. So now this data we will pass into our model. So this polynomial object is creating those many columns. Okay. So again, test poly data. I'll rename this simply test poly data. Okay. So this is our test poly data. Now to pass this test poly data into our model, all I have to do is to do like this key model dot predict. And for that, we will pass our this test poly data. Okay. And now what it will do, it will give us some output. So you can see that this is our output. Now, the way we designed our model, this output is already this data is already in your log format. So to convert this log into a normal, dollar format, what you have to do, you have to take exponent of this particular log. So np.exp, I'm just doing np.exp exponent of this particular log. And if I run this, now here you can see your insurance premium. So this is your insurance premium. So if a person is of 25 years of age, has 22.6 BMI, there are no children, he is a non-smoker, the insurance premium he has to pay is 3,103. Okay. So this is how we are getting our prediction. Okay. So I hope this process is clear that we have covered here. Okay. So from scratch, I have shown you how to get prediction from your model. Okay. First, we have imported our libraries. Then we have loaded our models. We have loaded our joblib model, normal model, linear regression model. And this is our polynomial object. Okay. So we have also loaded this with the help of joblib. Then what we had done, we had taken user input. So this is our user input. So whatever data user want to enter, user can enter like this. Okay. And then what we will do, we will create this particular data in the form of a numpy array, and then we will pass this particular numpy array inside our polynomial object. Now, polynomial object will transform your test data, whatever data user entered. And then this transform data, again, we have passed in our model. Okay. Now, this model.predict will give us predictions in terms of log. And to again convert the log into your normal values, we have taken exponent here. So this is the process of getting prediction from our model. So I hope this part is clear. So there is a question from Tarushri, how we convert our model file into joblib file. Tarushri, it is extremely simple. The code is exactly like this, joblib.dump, and then you have to pass your model. Okay. The code is extremely simple. Just search joblib.dump and you will get your syntax. It's a one-line syntax. Okay, nothing fancy. Okay. All right. So this is how we'll get predictions. Okay. Now our main question is how to create an app.py file. So it'll we will not going to take input from a user in a UI way. We will take input from a user in a more code format way, that the way that we have given here. and then it will again return us out an output, but it will return us output in a form of a from a Flask server. Okay, so now we will create our app.py. So what I'll do, I'll just again create a new file and name it app.py. Okay, now for the sake of saving time, what I'll do, I'll take help of this previously built app.py file. So I'll not type the whole file, because if we are going to type this whole file, then it will take so much time, because we have to cover more stuff also. So here is our libraries. Okay, so I'll explain every part of it, don't worry. So I have created this app.file here in this particular folder, and now I'll paste this. So these are all the libraries that we are going to need to run this particular app.py file. Okay. All right. So this is the library. Now again, what things that we have to do? First of all, again, if I go to this, first we will initialize our Flask app. Okay. So what this syntax will do, this syntax will initialize your Flask application. Okay, so this is your Flask. We are creating a Flask object app. Okay, so this Flask is a class. Flask is a class, and this underscore name means we are giving its name as app. Okay, so the name of our Flask is known is app. Okay, so this app is nothing but an object of our Flask class. Okay, so we will see how we will use this app. Okay, so we have initialized the Flask app. Now, next thing what we will do, we will load our models. Okay, how to load our models? We have just done that. Okay, so I'll use the same syntax. Okay, this is our syntax. So I'll just copy this from here and paste it here. Okay, so this is model, this is your poly object, and we have loaded these two models. Okay, check it. Next, what we will do, we will create a function. Okay, a predict function that will, what it will do, it'll take it'll give us the output from our server, Flask server. So we will write a function that will give us the output from our Flask server. So I'll just explain how it is working. So your first line is this. Okay, @app.root/predict method equal to post. So what this line will do, I'll just give you a brief intro. So as you have known, this @ is nothing but a decorator. So whatever function that we are writing below this particular line is going to pack itself in a Flask server, application kind of thing. So what you are doing, what you are saying to Flask, so whatever function you will find below this particular line, you have to route this particular function to this particular URL. So whenever in your browser, you will say your Flask start on a particular port. Okay, I'll just explain it thoroughly. So yes, so suppose your Flask start at a particular port. So in our case, we will start our Flask in this particular port, the 127.0.0.1, then colon 8080. Okay, so we will start our Flask at this particular port. Okay, now after this, if you write like this, /predict, okay, whatever that you have mentioned here. So this /predict will give you a response. So whatever function you have written over here, its output will be shown to this particular URL. Okay, so this line, what this line is saying, whatever function that you'll write below this particular line will give its output under this URL. Okay, I hope this is clear. This part is clear, what this /predict is doing. So this is a part of a URL that gives you the output of a function, whatever function you will write below this particular decorator. Okay, and again, you have mentioned here what type of data that is handled by this predict is nothing but post. So if you have learned about Flask APIs and all that, there are various things like get request, post is there. Okay, so there are various things like this. So get is nothing but when you get data, when you pass data to your server. Okay, And post is what? When you receive your data from your server. So what we are trying to do, whatever our model is giving us output, okay, a server will give that particular output to us with the help of this post request. Okay, so we have mentioned here particularly that what we are doing, we are packing this particular function like this post request. Okay, so this post is nothing but we are getting output from our server. It is only specifying us that we are getting output from our Flask server. Okay, so this particular line does what? Whatever function you will return below this particular line will give its output under this /predict URL. And you specifically mentioned this method equal to post to say that this particular function will give output from our server, Flask server. Okay. Okay. So I hope now it is somewhat clear. Okay. See, so there is a question from Soumya, app.root. So this app.root is nothing but is a kind of syntax that, see, this app is nothing but your Flask, okay, Flask thing. And you are, routing whatever your output is, you are routing to a particular URL. Which URL? This /predict URL. Okay, you are routing it. And you are also mentioning the method, ki how, the data is coming. Okay, you will see it more when we do some practical, you will again understand it more. Yes, you can use Fast API also. Okay, I have chosen this Flask API, nothing special about it. Okay. All right. So yes. So now what we will do, we will write a function. So I'll create a function here, def, and the function is again predict. Okay. So this is our function. So whatever our function will give output will route to this particular URL. Okay. So def, okay, predict premium. So I'll just copy this particular function and explain it to you what it is doing. Okay. So I'll just copy this up till here. Okay. Okay. So see what this function is doing. Okay. So this is your def keyword. It is used to define your a function, and this is your function name. Okay. Predict premium. Okay. All right. So now what we are doing. So we are taking our data. So this data is nothing but we have a request library, and inside that particular request library, what will happen? So when we hit our Flask API server, we hit our Flask API server with the help of a request command. And inside that particular request command, what we have, we have to pass our input data. Input data means this data. We have to pass our input data. What is the age of a customer? What is the BMI, and a number of children and a smoker. So we have to pass all this particular data. Okay. So this request.json. So what this .json will do, it will create your input data in a form of a dictionary. So I guess many of you have heard about JSON format. Those you have not, just think of it right now like this. It is very similar to your dictionary. I guess everyone is familiar with Python dictionaries. Python dictionaries are nothing but your key value format, key value pair format. So you have this key one here, and corresponding to this key one, you have this value one. Then you have this key two, and corresponding to this, you have value two, and so on. So like this, you are creating your data. So whatever data that you are sending to your Flask API, okay, it'll you are formatting it to your JSON format. Okay, and this particular data, you are storing it inside this data variable. Okay, so data variable contains our input data in the form of a JSON format. Okay, this data is nothing but our data like this. Okay, so in this, for example, I'll say that age, suppose 23. Okay, then suppose BMI is 22.6, something like this, and so on. Okay, so our data is nothing but like this: age, BMI, okay, and all those things. All right, so our data is like this. Now just see here. Now what we are doing here, we are doing data.get. Okay, so I'll just ask you a simple question. I think every one of you is familiar with Python dictionaries. Say yes or no. Okay. So my simple question is, so suppose if I want to extract the value of age from this particular dictionary, what will be, how will I write like this? Suppose my dictionary name is A, suppose, okay. And I want to extract the value of age, that is 23. How can I do this? Yes, Himanshu's answer is right. A dot get age. Okay, we can also do like this: A square bracket age. Now, what is the shortcoming of this method? Ki suppose again, if I write something like this, ki suppose age one. Okay. Now this age one key is not there inside my dictionary, so it will give me an error. Okay, this particular thing will give me an error. Okay, so instead of that, if you heard about dictionary methods, there is one dot get method. So what this dot get method will do, you will pass your key here. Okay, so if data is present of that particular key inside your dictionary, it will return that particular data. And suppose if data is not present, suppose there is no age name key in your dictionary, and then apart from that, if you mentioned here 21, so in this particular case, your output will be 21. So if you don't have this particular data inside your dictionary, then it will return this default value. So now you can see that we are doing exactly like this. Data is nothing but your dictionary. So data dot get, and then we are querying our key parameter, whether you will find this, did you find this age key inside your data dictionary? If yes, then give that particular output to this particular variable. If you didn't find this age variable inside this data dictionary, then give this output 30. So I hope this syntax is clear to you guys. Dot get method from your dictionaries. Okay, it is absolutely same that you have used in Python. Okay, good. All right. So as you can see that we have get all those data from your request.json. Okay, and again what I'll do, because I have realized it just now, we are not using this gender column to make our final prediction. So what I'll do, I'll just remove this gender column from here. Okay, so I'll not take this gender data here. Okay, because in our final prediction, you can see that we are not using this gender data. Okay, so okay, so from our request library, from our request data, whatever we are requesting to our Flask API server, we are extracting these datas from our request format. So this is our data. Okay, so our data is like this. Now what we will do, now we will convert the categorical data to numeric data. Why we need to convert categorical to numeric? Because our model will not understand no and yes of a smoker. Okay, because our smoker column is no and yes, and our model is not able to understand that. So what we are doing here, we are converting. So if smoker value is no, then it is 0, else it is yes. Okay, so like this, we are converting our categorical data to numeric data. Okay, simple stuff. Okay, so up till now, what we have covered in this function, we have received request to our Flask API server in a form of a dictionary. Okay, first thing is we have we have received a request in the form of a dictionary, and in that particular request, what we are doing, we are extracting particular data that is needed for our prediction. Okay, so from that particular dictionary, we are extracting age part, we are extracting BMI part, we are extracting children and smoker part. Okay, like this. Now, again, next, what we are doing, we are creating a test data. So this syntax we have already done. We have created this test data. So whatever data that we have collected earlier, we are using that particular data to create a NumPy array. Okay, so straightforward syntax. Okay, and this is our test data. We stored a NumPy array in our test data. Okay, now instead of this poly object, its name is poly. Okay, so now you can see that as we have created our test data. So next thing what we will do, we will transform this test data with the help of polynomial object. Okay, so this thing we have already seen in our Jupyter notebook. Okay, so we have passed this test data into this poly object, and this in turn will transform your data into test poly. Okay, now this, for this test poly, what we had done, we have passed this test poly into model.predict. Okay. Now this model will give us output in log format, Vipred log. It is giving us output in log format. And then what we are doing, we are converting this log to actual values with the help of this syntax np.exp, and we have passed this particular log thing. And now this is our Vipred. Okay. So this is our final prediction that we have to show. Okay. All right. So up till now, the code is straightforward. Okay. I guess you guys are clear what we had covered here. Okay. This function is straightforward, nothing special in this function. We have received a request in a dictionary format. Then we have extracted the relevant information from a dictionary. And after that, we have arranged all that information in a NumPy array. And after that, we have transformed our data using a polynomial object. And after this data, we have passed it into our model. And then we have taken exponent of our model's output to get our final prediction. Okay. So like this. So there is a question from Vaishnavi. Is using poly object compulsory? So Vaishnavi, it is not compulsory to use poly object in every deployment thing. But the way we have made our model, linear regression model. Okay. So when we are creating this particular model, when we are solving for this particular data, we have find that by creating polynomial objects, you are getting a better result from your model. So I have included that particular polynomial object transformation while predicting your data. Okay. So it is absolutely not necessary to include any transformations in your predictions, but it is a part, it is a process how you will get a proper prediction when you are solving your problem, and then particular how you will implement that particular pattern or particular path when you're deploying also. So this is a part of that particular process. So I have to include this because it is the process that I have followed while creating a model. If I don't follow that particular process while creating my model, I don't have to do this. Okay. All right. So Ravikash also said that, can you explain what what is poly features? Okay, so there is a lot of confusion around the polynomial features. So I'll explain it one more time. Okay. So see, what does this polynomial features are doing? Okay. Just a minute. Yes. Now, so what does this polynomial features are doing? Suppose you have a data like this, X is your data. Right? And suppose in polynomial features, you have set degree to 2. Okay. So there is a degree parameter in polynomial. So degree to 2. Okay. So what this degree 2 will do? It will create feature like this: X raised to the power 0, X raised to the power 1, X raised to the power 2. So suppose if the value of X is 5, then its output is 5 raised to the power 0, 5 raised to the power 1, 5 raised to the power 2. That is 1, 5, 25. Okay. So it will create 3 columns from this particular data. Okay. So this is degree 2 polynomial. Okay. This is degree 2 polynomial. And in our case, we use a much higher degree of polynomial. So if you see here, okay, if I just print this test poly data, so now you can see that these are your various columns. Okay. So we have this age column, BMI column, children and smoker, and you can see that you will have all those particular columns. Okay. So here, if I remember it correctly, I have used polynomial degree 3 to 5, I guess. So 3 to 5 means 5 raised to the power 3, 5 raised to the power 4, and 5 raised to the power 5. Okay. So like this features. Okay. I have not exactly remembered that, but something like this. Okay. So like this. So these are our polynomial features are doing. So in linear regression, when you make your data complicated, your regression line tends to curve much. Okay. So if your regression line is curving, or if you are making a complex decision boundary, then it is likely that you are, moving from a more underfit model to a more generalized model. Okay. You don't have to make it more a highly complex model, but to increase your complexity of a linear regression model, all you have to do is to make your data more complex or to have more number of columns. So this is a separate discussion around how to build a model, okay? How to select a perfect model. So this is not a kind of, motto of our lecture, okay? Our motto of our lecture is you have a particular model from which you are satisfied. Now you want to deploy that particular model, okay? So again, let's go back to our app.py file. So I hope now this polynomial feature thing is clear to you guys, okay? Okay, so polynomial features are nothing but it is creating some extra features. So suppose if a particular column is having a value 5 and you have created polynomial features with degree 2, it will create 3 more features, okay? Your column raised to the power 0, your column raised to the power 1, your column raised to the power 1. Oh, sorry, 2. Okay. So like this, it will create these 3 features. Okay. So this is only what polynomial transformation is doing. Okay. All right. Okay. So now it's our last part. So see what we are doing here. So we are again returning. Okay. So what does return do in a function? It will give you some output. And we have already say that. So whatever the output of our function, it is available at this particular URL. So whatever we are mentioning in this return, it is available as an output from our Flask server. Okay. So what we are taking as an output. So here you can see that we are using JSONify. So JSONify is nothing but creating your dictionary into a JSON format. Okay. So this is what we are trying to create, and we are converting this particular thing into JSONify. Okay, so one thing to note that this JSONify thing is not kind of mandatory to use here. But if you use particular JSON format as an output of your Flask server, so what it will benefit you, because various cloud platforms like GCP, Azure, AWS expects your server to return output in a form of a JSON. So it will be much more convenient, or you say that much more less error prone for you if you kind of get your output of your from your server as a JSON format. So that's why we have converted this into a JSON format. Okay, it is nothing but a dictionary. Okay, think of it like a dictionary. It is nothing special but a dictionary. And what it will do, it will deployment more easily. You will receive much less errors. Okay. So that's why we have done JSONify here. Okay. So what we are outputting, we are creating a key with the name insurance premium. And what is the value of that particular key? The value of key is this particular thing. So whatever you are getting output of your model, okay, so your output is in a form of a NumPy array. So we are accessing its zeroth element. Zeroth element means that particular number. Okay, we are accessing that number only. And if our number is quite long, for example, you can see here, this is our output ypred. So if we access its zeroth index, so zeroth index is nothing but your data. And rounding this data to 2-digit means you are rounding this particular thing to this particular amount. Okay, so 3103.73, like this. Okay, so you're doing like this. Okay, so this is the output of our function. Okay, so this is our main function that we have written. Okay, whatever whatever request that we have received to our server, we will extract our data like this. Okay, after extracting data, we will pass this data to a NumPy array, and then we will pass this NumPy array to a polynomial object. After this polynomial object, we will pass the output of polynomial object to our model, and then output of our model to an exponent. And whatever the output we have received after this exponent, this exponent operation, we will return this as a function output in JSON format. Okay, so this is what our function is doing. Okay, we will take our data, we will process our data, we will get prediction from our data, and after getting prediction, we will again returning in a form of a JSON. Okay, So there's a question, can we return ypred without index? Yes, you can do ypred without index, but then it will return you an array. Okay. So just for the sake of display, I just want to display number rather than an array. Okay. So that's why I have taken the 0 index. Okay. See, those who are having confusions why we are taking 0, you can see it here. So if I do ypred, okay, ypred is not defined here. I'll do this ypred here. Okay. Now if I run this ypred, so ypred is nothing but this array. See, this is an array. Now I just want to extract this number. How to extract this number? I have to use the 0 index. So if I use the 0 index, I'll just get this number. Okay. Okay. And now if I want to round this, again, I can do np.round or simple round, and you will get this rounding with 2 digits. So now you can see that 3103.73 is your final answer. So I want output like this. Okay. You don't have to do this, but we are doing this so that our output is clean and nice. Nothing else. Okay. All right. I hope now it is clear. Good, good. All right. So what we had done here, we have created our function. So this is our main function through which we will get our output. Okay. And now the main part. Okay. So now what we will do next. So this is the main thing. Okay. So this file or this app is only run when we run this using in this particular folder only. So if we are running this particular thing in this particular file using in this particular folder only, then only it will run. Okay. So if dunder name, so this double underscore is nothing but dunder. Okay. So if this is equal to main, if the name of your file, for example, if this particular name, whatever name that you had mentioned here, if this particular name is equal to main, then what you will do, you will run this app file. App is what? App is this, your Flask object. Okay. You will run this particular app. Okay. So this is a kind of a security code. So this only tells you ki please don't run this file from another folder, only run this file from this particular folder. Okay. So that accidentally you can't run this particular file. Okay. So this is just for that. So app.run command is used to run this particular Flask app. Okay. That you have created above. And here is some interesting thing. So here I have specifically mentioned these two things. Okay. And these two things are specifically for your Docker and your GCP thing, because I have faced a lot of difficulty to run, this particular app in Docker or in GCP if I didn't mention this. Okay. Because a lot of port issues are there. So GCP default port for GCP is 8080. Although you can change your port inside this GCP, but again, don't know what error will come. Okay. So I'll just make sure that my Flask API port and my GCP port are same so that I can get my output. So GCP is using 8080 port. Okay. So I have also mentioned, please give this particular output to this 8080 port. Okay. And what does this host 0.0.0 will do? It will make my output available in outside my host. So outside my host also it will make my output available. So I'm able to access from other IPs apart from my host IPs. Okay. So these two things will help help me a lot for getting predictions from my Docker, because Docker is also a separate environment. GCP is also a separate environment. Okay. So like this. So these two things are specifically for Docker and GCP. Okay. So this is our final code. So this is our app.py file. This is our, complete file. Okay. So Soumya's question is, what is main? Okay. Yes, Soumya. So this main is nothing but, so this, refers to your class objects, your oops concepts. Okay. So if you have a class initialized in a particular folder, and if you're accessing it or you are accessing it using from a same file. So suppose If I run this app in this file only, okay, then the name of this particular app is main, because I'm running this particular app through this particular file only. Okay. And suppose again, if I create a new .py file, and inside that new app.py, inside that new .py file, suppose I'm calling this particular object, then the name of that particular object got changed. Okay. Then the name of that particular object is app. Okay. But if you are accessing it in this particular same file only, means you have defined your object in a file and you are accessing it also from the same file, then the name of the object is main. So you are telling here, if the name of your object is main, matlab if you are accessing it, your object using inside the same file only, then what will happen? Then only run this particular thing. Otherwise, don't run this particular code. If you are accessing it outside your through your different file, then don't run this particular thing. Okay. So this is just for security purpose, nothing else. Okay. All right. Yes, you like void main, exactly like this, Mohit. ठीक है. So this is your code. Okay, so we have completed our app.py file. Very good. So now the next thing what we will do, we will test whether our app.py file is working or not. Okay, so let's see whether it is working or not. So for that, what I will do, I'll open a particular terminal. So I'll open this terminal. So this is our terminal inside our VS Code. Okay, so now to run this particular file, so first of all, I'll just save this file, Control S, save. Okay, now to run this particular file, what we have to do, we have to run it like this, Python, and the name of your file is app.py file. Okay, so when you hit enter, your app.py file is going to run. Okay, and we are executing this app.py file inside our virtual environment. So whatever libraries that we have installed, our app.py file will run using those libraries itself. It will not use my global environment libraries. Okay, like this. So I hit enter. Okay, so now you can see that it is giving me an output like this, key running on all addresses. So this is your port on which you will get your output. Okay, so this is our IP address on which we will get our output. Which output? This particular output. So the this slash part, this slash URL is nothing but this URL. So we will be using this particular address to access our predictions. Okay. So unlike our Streamlit app where we have a nice UI where we can interact, now we will interact our model with the help of this API. Okay, now we are interacting with the help of Flask API. So how to get predictions? Okay, so there are two main methods that we are going to cover. So for that, what I will do, I'll again create a new notebook. Okay, or what I will do, I'll just copy that particular notebook. So I have already created this get prediction notebook. Okay, so I'll just copy this particular, copy this, and I'll paste it here. Okay, so get prediction is this. So let's see. Okay. So to see, to get predictions, there are two formats or two things that we can do. Okay. So first one is your curl. Okay. So curl commands are nothing but client URL. So this is your client side request that you are sending to your server. Okay. And again, one is your request using request library. Okay. So we'll see both of them. All right. So let's see. So I'll just explain what we are doing here. So this is our command. Okay. So in this command, what we are doing, this is curl. Curl is your client URL. Okay. And then we are mentioning here that we are using, we are sending it to our, server. Okay. We are using a post command. Okay. And on which address we have to post this? We have to post this on this particular address. Now see why we have chosen this particular address. See, this is your home URL, http:// //127.0.0.1:8080. So you can see that this is your home address. This is your home address that you're on which your Flask API is running. After that, why this slash predict? This slash predict is nothing but you have mentioned specifically here कि whatever the output of your function, please give on this particular URL. Okay. So we are adding this slash predict after this home URL. Okay. So this is very similar to how you will access your URLs over web. For example, if I open any particular URL, okay. For our case, if I do something like this, so see here. So this drive.google.com is your home page. Then /drive is your again next URL. Then /folders is again your next URL and so on. So suppose if I go to this /folders and if I hit enter, okay. So if I leave, so you see that I am on this particular folders. Okay. Again, if I again, go to this particular, again, some other folder and all that. So it will give me some other URLs. So let us do some other examples. So suppose I'll go to this W3 school, suppose. Okay. So this is a W3 school URL. Now, if I hit this Python, so you can see that after this W3 school, you have this /Python. Okay. And then this default.asp. Okay. And then suppose if I go to this Python Boolean, okay, then inside this Python, I am using this Python Boolean.asp. Okay. Again, if I have to go to your homepage, I just have to erase all those and just hit this. So again, I'll get to my homepage. And if I have to go to this Python, all I have to do is to write like this /Python. I hit enter. And now you'll see automatically I'm redirected to this Python page. So we are also doing the same. Okay. What we are doing, this is our home URL. This is our home URL. And after this home URL, we are redirecting ourselves to predict page. Okay. So we are redirecting it to our this particular page. So I hope this line is clear to you guys, why we are doing this. Just let me know if this particular part is clear. Okay. See this -x, -h, -d, it is all your format inside this your curl. Okay. You are specifying it. Okay. You are sending this particular URL. You are sending this particular format. Okay. It is your standard format in this curl thing. Next is your content type. So this is nothing but you are telling this, you are sending it in a form of a JSON. Okay. You are telling it, you are sending your, data. This is just for information purpose. It is in JSON format. Okay. And what is in JSON format? This is your main data. Okay. This is your dictionary format data. So whatever data that we are reading in our predict function, so we are sending our input data like this. So for our age column, age key, our output is 30, our value is 30. For gender, our value is male. So we are not using gender. So I'm just removing this particular thing. Okay. Then for BMI, our value is this. For children, value is this. Smoker, value is this. So this is what? This is our input data. Okay. So what we are doing, we are on this particular URL, we are sending this data. Okay. Again, I'm repeating, on this particular URL, we are sending this input data. Okay. And when we send this particular input data to this particular URL, what it will do, it will execute this function for us. So whatever function that we have returned in our application, our function get executed. So let's see. So if I run this particular cell, now you will see that I'll receive output like this. Okay. So insurance premium. So insurance premium, why I'm getting this particular key? Because you'll see that in our app.py file, what we are returning like this insurance premium, it is equal to this. So you can see that in this particular format, I am getting my output. Okay. So insurance premium is 4,135.81. Okay. Just a minute. So I hope this particular thing is clear. Okay. All right. Okay. So this is your first format. This is a first method how through which you can interact with your API. So you can see that now I am able to interact with my model with the help of this particular URL. Okay. So I can be on any folder at any kind of inside my system. I can be anywhere and I can take output from my model with the help of this particular URL. Okay. All right. So this is our first format. Now next format is, see, with the help of this request library. So with the help of this request library, what we can do like this request.post. Okay. So again, we are using this post method, and which URL we are using? Again, we are using this is our home URL /predict. Okay. And inside this JSON format, we are passing this data. Okay. Age, gender, BMI, children, smoker. Okay. And again, I'm just removing this gender part because we are not using it in our model. Okay. So this is our JSON format data. Okay. And again, so this is our response variable, and this then response.json get the JSON dictionary from the response. So basically this is our response and we are getting this JSON dictionary, this part. Okay. And this is our result. Okay. So what we are doing, request.post. So on this particular URL, it is passing this data, okay, to this URL. And when it passed this particular JSON data to this predict URL, this particular thing will give us result in form of, again, this thing. Okay, we will get a result like this. And what we are doing, whatever response that we are getting, we are accessing its JSON part and we are printing it simply. Okay, so again, if I run this particular thing, now you can see that I'm getting the same answer that I have been getting here. What is the difference between the two URLs? Two URLs. See, the URLs are same. This URL is also same. Okay. And this URL is also same. We are using the same URL. Okay, there are two URLs as a home URL and not the second one. Okay. Yes. So yes, this one. So yes. So see what this is doing. Okay. So these two URLs are only getting generated because of this, because the way I have mentioned it here. Okay. So this is my local URL, the URL that will work on my system. And this URL is for other environment. Okay. Other environment means, suppose if I am running through Docker or if I am running through GCP, then what will happen? This is the URL on which I am able to access my data inside Docker or inside GCP. And the above URL is that URL on which I'm able to access my application in my system. Okay. So in Docker also, we will be using this URL only. We will not be using this URL because this particular URL represent first you have to go inside Docker, and then you can use your application inside Docker with the help of this URL. Okay. So if you don't use this thing, host equal to this and port equal to 8080, then you will only get a single URL. Okay. So all the three URLs are just because we are using this part. Okay. And in all the cases, we are using this host URL only. Why? Because we are, consuming our application in our host machine only. We are not consuming our application in, any, web UI or any outside cloud environment. Okay. So in every case, we will be consuming our, API inside our laptop only. Okay. So that's why we are using this. This is your home URL and this is your other environment URL. Okay. All right. So these are the two methods through which you can get your predictions. So, okay. So I hope these two things make sense to you. Okay. We have created our app.py file using Flask. Okay. And then what we had done, we have run our Flask server. So see, our Flask server is running now. Okay. Our Flask server is running. On this particular Flask server, what we are doing, we are getting predictions. Okay. Using this URL. Okay. Through these methods, we are getting predictions on our Flask server. Okay. So suppose what will happen if I close this particular Flask server, suppose if I hit Control C, now what will happen? Our Flask server got exited. Okay. Now, if I run this particular thing, so suppose what will happen if I run this? Okay, again, it is giving me output. No, it will, no. It is running or not, or what? Okay, wait, it is asking me to select. Okay, sorry. Okay, actually our output is not there. Okay, now it is running. Okay, so just wait for some minute. So see what it is doing. It is giving me an error. See, there is no output. Okay, what it is giving me, failed to connect to this particular port. Okay, couldn't connect to server. Why it is not able to connect to a server? Because we have already stopped our server. You see that our server got stopped. Okay, and suppose if I again run this particular cell, again it will give me an error. Okay, so now it is trying to connect to server, but there is no server. So it is telling me that max retries exceeded. Okay, so it will retry it many times and then it fails. Okay, and then it will give me an error. Now if I run my server again, so suppose again if I run this python app.py. Okay, so again your server is up and running. And now if you run this particular URL, now you'll see that you will get your insurance premium. Okay, same code, I did nothing, but now it is giving you your output. So why? Because we have start our server, and now whatever request that we are sending, we are receiving it on our server. And you can also see that our server is telling that, okay, we have this post request received, and this 200 means it has given its output. If it is 400 or 404 or something, that your server is not connecting or not running or something like this. Okay, so these are all the codes, your HTTP codes that you have when you connecting to a server, you will get. Okay, again if I hit this request library, again I received my output, and you can see that again it will give me a message. Okay, another request is received and it has served that particular request. Okay, so like this we are accessing our model with the help of Flask API. How I restart? I just have to run python app.py. This is our code. Python app.py. This is how you'll start. Okay, in app.py we have mentioned all our code, so we just have to execute that particular file. All right, so I guess this part is clear to you guys. So up till now, what we had done, we have created our model. We have created a Flask server, and we have successfully served our model with the help of Flask server. And then what we had done, we have received predictions from our Flask server. Okay. So I'll just take some 2 minutes time, or 5 minute time. So if you have any doubts up till now, or any doubt regarding the method that we have followed up till now, we can discuss. Okay. So we'll take a 15-minute break around 12. Okay. So after 2 hours, we'll take a 15-minute break. Don't worry. Okay. Anything else? So shall we continue? Uh, One session is complete. Can we get files from last class recording to our drive? Okay, I'll also share that to you right now. Don't worry about that. So this is our last master class, and so this is the last masterclass URL. You can also access that particular material here, Streamlit tutorial. Okay. All right. So part one is done. So whatever we have planned. So we are at we have covered a step one. Step one is what? We have successfully run our model using Flask API server inside our local environment. Okay. So our model is up and running with the help of Flask API. All right. Okay. Now the next and interesting part is how to Dockerize our this particular app. Okay. No, Soumya. For deployment, you can also use other things also. Flask is just a module. Okay. Other than Flask also you can use. Okay. In our last class, we have already discussed about Streamlit, how to deploy using Streamlit. Okay. But Streamlit is more kind of UI thing. Okay. This Flask is more kind of your API thing. Okay. So next part is you have to Dockerize your app. So just tell me, what is the need of Dockerization? Did anyone know what is the use of Docker? Why Dockers are used? Anyone? Okay. It makes cloud platform independent. Good. Version conflicts. Okay. So version conflicts we can also solve using virtual environments. Then why Docker? No dependency required. Okay. Good. Running multiple of applications in one single cloud. Not exactly. It makes it, yes, it makes easy to deploy. Containerization, yes. Okay. All right. So we'll see. So see what Docker is doing exactly. Okay. So think, suppose what we had done here up till now, we have created a folder. Inside this folder, we have various files. Okay. We have various files. Okay. And inside this folder, we have also created our .venv file. venv is nothing but our virtual environment. So on this virtual environment and all those other files, app.py file, okay, and your joblib file is there. Okay, so with the help of all these files, we have successfully run our Flask, kind of application. Okay, Flask API. Suppose I want to deploy this particular thing, okay, into any cloud or any other computer. Suppose you again wanted to test whether this particular thing is working on your computer or not. Okay. So what is the best way that I can share my code with you? Okay. One thing is that I'll send you all these app.py file, joblib file, and this requirement.txt. Okay. I have to send all these files. Then what you have to do, again, you have to create a folder in your system. You will paste all those files in your system. And from this requirement.txt, what you will do, you will create a virtual environment. So after creating this virtual environment with this requirement.txt, now you can able to run this app.py file and joblib file. Again, you can able to run this thing. Okay. So this particular format is like this. You'll share your this requirement.txt file. With this requirement.txt file, you can create a new virtual environment, and inside that particular virtual environment, you can run your application. Okay. So you can see that all of these things are kind of, quietly loosely coupled. You can say that very process oriented things are there. Okay. So you have to cut, you have to paste, and you have to do all those things like there. Okay, like this. So instead of doing this virtual environment thing, what we can do, can we pack this whole thing inside a container or a box? And if I can able to export this container to you, then again you can use this container to run your application. Okay, so this is the main concept of Docker. Okay, so whatever the configuration file, whatever the files that you needed to run your application, you containerize those particular files, and you can use that particular container to run your application. Okay. Okay, so the Tanushri's message is there. Can we take 5-minute break? Okay, Tanushri, let's just wait for 15 minutes. At 12 around, we will take a 15-minute break. Okay, don't worry. Okay, let me explain the theory of Docker. Then we will, after break, we will see its practical. Okay. So like this. So this is your Docker container, and you will export this Docker container to another person or anyone to run that particular system. Now, what's the problem with that particular thing? The problem is that once you export this particular thing, to another person. Okay. What you have to do, again, there are a lot of configuration file, there are a lot of setup files also. Matlab, you can't export whole virtual environment or whole virtual box to another person. Okay. So instead of that, so instead of sharing containers, so this thing that I have built here, this is nothing but a container. Container is nothing but a virtual machine. Okay, a kind of virtual machine. Any one of you heard about virtual machine? What do you know? What do you mean by virtual machine? Virtual machine, anyone? VMware, VirtualBox, have anyone used? Running multiple OS in a single OS. Very good. So what does this virtual machine, virtual environment is different. Virtual machine is different. So what this virtual machine will do, it will create a separate operating system inside your, operating system, whatever operating system that you are using. So suppose on Windows, if you want to use your Linux, then with the help of virtual machines inside your Windows, you can create your, virtual machine. So in virtual machines, you have separate OS and your OS has separate kernel also. Okay. So kind of it is completely standalone operating system installed on your system. Okay. So they are quite heavy. Virtual machines and VirtualBox are quite heavy. Okay. So what different Docker is doing, Docker containers are nothing but Docker containers are kind of your virtual machines, but for they have their OS, they have their libraries, but the kernel that they are using, the kernel is shared. Whatever the kernel, whatever the operating system that you are using, so the kernel of your operating system is shared by your Docker. Okay, so your system is kind of separate, but all the heavy stuff that it is doing to run this particular Docker container, it is doing it outside its container thing. Okay, so it is kind of a virtual environment that is separated from your rest of your PC. Okay, so it is a light version. Okay, light version of your virtual environment. So they are quite easy to share. Okay, containers. Okay, like this. Okay, so again, but there is a problem here. So suppose if you make a container, so container size are, again, it depends on your application to application, but container size are quite huge. Okay. Like this, you can also have it in GBs. You can also have it in, because the container that we had, that we will be making it is somewhat around 150 MB something. Okay. No, I guess, yes, 470 MB something. Okay. So 470 MB something is our container size. Okay. So this particular thing is not easily shareable. Okay. So what Docker is allowing us to do, whatever things that we had mentioned here, we can compress, or what you say, we can write all the process in a form of a image file, Docker image file. So Docker image is nothing but your process. Ki do this, do this, do this, do this, do this. Okay, kind of a recipe book. Okay, so if you want to make, suppose cake, and you have a cake recipe, then with the help of this recipe document, you can make various cakes. Okay, so this recipe is your Docker image, and these cakes are your Docker containers. Okay, so sharing this Docker image is quite light. Okay, and with this Docker image, we can create multiple containers. Okay, so next what we will do, we will see how to make this Docker image. First, we will make a Docker image for this particular application, how to make a Docker image. Then what we will do, with the help of this Docker image, we will create a container. Okay, a Docker container. Okay, and with the help of this Docker container, then we will run our application. Okay, so application is not run by your Docker image. Docker image is just your recipe, a text document or something like this. Not exactly text documents, it contains various layers, but you can think of it like a text document. Then with the help of this Docker image, you will create a Docker container. Now this Docker container is a fully functional thing that you can use to get your predictions. Okay, so with the help of this Docker container, we will again run our applications and getting our predictions. So I hope this workflow is clear. What we are trying to achieve with the help of Docker here. Okay, good, Janish. Okay. All right. So the first process is to create a Docker file so that we can pack our, data. So how to pack our data? Okay. So we will see how to create our Docker file. Okay. So before doing all this, okay, so suppose if you want to do it yourself. So first of all, what you have to do, you have to install Docker inside your system. So to install Docker, just go to this Docker thing. Okay, just type Docker and docker.com. Okay, you'll go to this docker.com, and for this Docker, inside this docker.com, you have to download this Docker desktop. Although it is not necessary, but it will help if you download it. Okay, for new users it will help. Okay, so you have to download it for Windows. Okay, so if you hit this something 400 or 500 MB something, this application is there, so it will get downloaded. Okay, so your Docker desktop is something like this. Okay, but okay, again, what you have to do, you are installing it for Windows. Okay, so suppose if I hit on Windows. Okay, I don't have to download it, and because for Windows also you have to install a WSL for Windows. Okay, so suppose if I see here, it must be mentioned somewhere for Windows. I'll search it, Docker for Windows. Okay, for Linux and Mac it is quite straightforward. Okay, there is no issues, but for Windows we have to do something. So you can download Docker desktop with the help of this particular thing. Okay, Docker desktop for Windows. Okay, then system requirement is what? You have to install one of these, WSL2 Hyper-V or WSL2 backend. Okay, so in my system I have installed this WSL, Windows subsystem for Linux. Okay, so in background it will need Linux to run. Docker need Linux to run in background, so you have to install this particular thing, and this is quite straightforward, nothing much okay fancy here. You just have to go to its documentation, Microsoft Windows documentation, and follow the steps are quite straightforward. Okay, just in PowerShell you have to run this, and all the things are will get installed. Okay, so it will download Ubuntu to your system, and again it will update that Ubuntu, and after this WSL got installed, then you can proceed with this particular Docker desktop download. Okay, so these things you have to follow. Okay, so I'm not covering this because installation will take a lot of time, but these are the things that you have to follow. I have already installed these particular things. Okay, all right. So like this. So after installation, you'll see, again, I have to open. Here is Docker. Again, I have to. Docker. So this is your Docker desktop. So, all right. So this is your Docker desktop. Okay. So it has your various images. It has your containers, volumes. Okay. The Docker is again quite detailed. Okay. Not just for data science, but for ML ops or DevOps persons also. Docker is widely used. Okay. So these are your some various images. Okay. Various images that I had created. Okay. So like this. So these are the images, and from these images, you can make all those containers. So these are the containers. These are your working, kind of environments that you can use to get your predictions. Okay. So like this. So this is your Docker. So next we will be using this Docker to get our predictions. Okay. So, all right. So this is the small introduction regarding Docker. So next what we will do, let's just take a break, and around 12:15, at sharp 12:15, we will resume with the practical part of Docker. All right. Okay. All right. Okay. So let's take a break. All right. Shall we start? Okay, let me see some chats. Okay, there is no record file in Streamlit Drive link that you should. Okay, so Mohit, I don't have recording there. All the material that we have covered in that particular session is there. Okay, there is no recorded lecture there. So whatever the code files, the whatever thing that we had done in our previous masterclass was there. Where can we access previous session? That you have to check with Ematicus, okay, where you can get that particular thing. Uh, recordings of whole sessions. See, recordings are huge. I can't share it on Drive. Okay, so that was my kind of personal Drive link is there. Okay, I hope. I think recording will be shared with you guys. Okay. Okay. See, Kuldeep, that ingestion in PySpark is out of scope of this present thing that we are doing. So we will deviate from our topic. So, uh, okay, later on we can have some masterclass on this. Don't worry about it. Okay. All right. So let's start. So where we are. So we have seen a little theory regarding uh, what is Docker, how you can run it, and I have also shown you uh, the Docker thing. When you install your Docker, you have one Docker desktop thing. That Docker desktop application is there, and your Docker desktop application is something like this. Okay, this is your Docker desktop application. So whatever images or containers that you will build using Docker will get you can see them here. Okay, so you can manage them here and all those things. So these are all the images that I had built for this particular masterclass. Okay. Uh, Okay, so initially I'm working on some other model to showcase you a sentiment analysis model of restaurant reviews that we have done here, a deep learning model. But the size of that particular thing is quite huge, 1.7 GB, something like this. And when I deployed it in GCP, there is some storage issues are there. So I have to move to a simpler model whose size is not that much. Okay. But I'll also show you what are the steps that I have covered in this particular model also. Okay. If we have time, then I'll also showcase this part to you also. All right. So yes, so we'll start. Okay. Okay. So what we had covered till now, we have seen we have created a folder. Inside a folder, we have this virtual environment. Okay. And with the help of this virtual environment, we have run our Flask API app. Okay. So we have run this Flask API app here. Okay. And we also get prediction with the help of this Flask API. Okay. So I have showcased to you how to get prediction with the help of this Flask API. Okay. So we had done that. Now suppose, so at this particular moment, we can also deploy our application to GCP. Okay. Nothing will stop us to deploy, there is uh, uh, there is not any mandatory step that you have to do Docker. But if you package your model with the help of Docker, your deploying is way easier. Okay. Very less thing you have to set manually. Okay. Okay, so what we are planning to do, we are planning to containerize all of this inside one container. And then what we will do, we will make this container inside our GCP. Okay, how we will make this container? So whatever the recipe for this container, we will make the recipe inside a Docker image. So first of all, we will create a Docker image. This Docker image will contain all the recipe for this Docker container. Now, with the help of this Docker image, we will transport this Docker image to our GCP. And inside GCP, with the help of this recipe, we will create our container. Okay, so that is our main plan. Okay, so that is our main plan. And if our application is working on Docker here, there are very less chances that it will not work in GCP, because all the environment thing and all the configuration things are already taken care by your Docker. Okay. Okay. So first of all, what we will do now, first of all, we will see how to create a Docker image, or how we can create Docker image of this app. Okay. So we will see that. Okay. The first target is to understand how to create a Docker image. All right. So let's go. So as you can see, this is our folder. Inside, you can see we have our requirement txt, polynomial object, insurance. Okay. We have get prediction and all that. And here I have pasted this Docker file. So this Docker file is nothing but I have created a new file like this, create a new file. And I had renamed this file to Docker file. So this is your standard format to name your Docker file. Okay. So inside this Docker file, I have created this Docker file like this. So I'll explain it line by line, what we are doing it here. Okay. Okay. So think of your Docker image like a recipe. So this is a recipe. And we are telling our to create a Docker image, we are telling that ki perform these steps. Okay. What are those steps? First of all, what we are doing, we are creating our image with the help of this Python version. Now, why I have chosen this Python version? Because this is the Python version. This is the version of my Python in my laptop. Okay, so the version of my virtual environment. Okay, so how to know which version you are using? So what you can do, you just have to go to this terminal thing. Suppose view terminal. Suppose this is your terminal. And you just have to activate your virtual environment. So to activate your virtual environment, just you have to do is .venv, then slash scripts, and inside your scripts folder, you have to activate this. Okay. So if I run this, so my virtual environment is activated. Okay. So yes, for this virtual environment, what I will do, I'll check my Python version. How to check your Python version? You simply have to type like this: Python space hyphen hyphen, I guess this hyphen version. Okay. Now hit enter. Now here you can see that my Python version is 3.12.4. So what I am doing here, I am taking official Python image from my Docker. So Docker also has Docker Hub. So in that particular Docker Hub, you have all the standard libraries are present there. So from that, I am importing this from Python 3.12.4. This is the exact same version that I am using here. Okay, why I am doing this? Because I want stability. Because if the thing is working on my PC, the same configuration I want to add to my Docker also. Okay, so like this. So this is your Python version. Now here is one more thing. See -slim. So what does this -slim represents? It represents light version in Docker. So in Docker images, whichever images have these -slim, so that means they are light versions of their original ones. So why we are interested in light versions? Because we want our Docker image to be as light as possible. Because again, if you deploy it on GCP, storage also costs. Okay. So we want to make this. So that's why I have using this slim version. So this is the base image on which we will do all our things. So we are installing Python here. First of all, we are installing Python in our system. Okay. Then what we are doing? We are setting working directory. What do you mean by working directory? Can anyone in chat tell me what do you mean by working directory? Okay, current directory. Mohit's answer is this. Present directory, very good. The folder in which we are performing task. Okay, good. Direct, which we are working on. Okay, so working directory is that directory in which your what do you say that Python pointer is. Okay, in which your Python is working. Okay, for example, if I just go to this test.ipynb, okay, just to showcase this thing. Okay, so if I do something like this, okay, I will first of all import this OS library. And from this OS library, I'm just getting get current working directory, get CWD, current working directory. So if I run this, it is telling me that my Python pointer is in this particular folder, GCP demo model. Okay. Now, if I do something like this, for example, cd and cd dot dot. Okay. If I do something like this and if I run it, okay, this command get executed. And now again, if I do something like this, os dot get current working directory. So now it should get changed now. Okay, let me do one thing. cd dot dot. Okay, shell command है यहाँ पर, ये चलेगा नहीं. Okay, तो यहाँ पे os command से ही we have to run. So os dot chdir. Okay, or chdir, suppose I want to do something. ठीक है, no issues. I will showcase you here. Okay, so suppose this is our this is the directory that you are getting here now. Inside your desktop folder, you have this GCP demo model, and this is where your pointer is. Okay, so if I do something like this, cd dot dot. Okay, if I run this, you can see that now our pointer is what? We have moved one folder back. Now we are on this desktop folder only. Okay, so this is your current working directory. Wherever your Python pointer is, that is your current working directory. And what we are trying to say here, set your current working directory to your home folder. After this home folder, there is one app folder. So set your current working directory to this app folder. Okay, so like this. So we are telling it in your Docker, set your current working directory to this particular folder. Okay, we are telling it like this. Okay, again, I'll change my current working directory because then it will change, do some issues. So cd, and then I'll do like this, GCP space tab. No, GCP space demo. No, I have to write it like this. All right. So cd, then GCP space demo space model, hit enter. Why it is giving me error? Okay, because of space. Okay, so I'll do ls. ls will give me all the files here, and GCP demo model is here. I want to go to this folder. Then cd space, maybe in quotes we can go there. Yes. So now again we back to our original folder. Okay, GCP model, demo model. Okay, so we are in this folder. So what we are doing here, inside our Docker, we are setting it. We set your current working directory to this particular folder. Why we are doing it? Because we want to ensure, because whatever path that we have given in our app.py now, so these are all the paths that we are given in our app.py file. Okay, so whatever path that we have given here, which path we have given here? We have given this insurance model path, this polynomial object path. So we want that our path must not be disturbed. Okay, so for that, to maintain the consistency, we are setting that key, okay, make this your current working directory. And inside this current working directory, we are performing all the things in our Docker. Okay, so we have set current working directory here. Okay, now next what we are doing, copy dot to this app folder. So what does this dot represents? Dot represents current working directory of my Python. So what is the current working directory of my Python? Just this GCP demo folder. So this is our current working directory. So whatever data that we are having in this current working directory, for example, this requirement.txt, test.ipynb, polynomial objects, insurance job lib, whatever things that we are getting here must be copied to this particular folder. Okay, so inside our Docker, inside your app folder, we are pasting all the files that are present inside our folder to this particular app folder. Okay, so we are copying all the content inside our Docker. Okay, now after copying all the things, what we will do? So if we copy all the things inside our Docker container, so you can also see that we also have this requirements.txt there. So requirement.txt will also get copied. And after that, what we will do? We will pip install this requirement.txt file. Okay, so inside our Docker, we will install our requirement.txt. Why? Because we also want whatever library versions that we are using outside our Docker, we want to have same library versions inside our Docker also. Okay. So we are installing all the libraries with the help of this requirement.txt file. Okay. And there is one more thing here is -- no cache dir. So what does this syntax will do? It will never use your cache data to install your libraries, or never save your temporary data into your cache for this requirement.txt. So this particular thing, it is not mandatory to do this thing, but if you do this thing, then what will happen is that you have lighter versions of your Docker images. Okay, because now you will not storing any temporary files or any cache data inside your Docker. Okay, so like this. So this thing will ensure that you have installed all the libraries inside your Docker. Okay, requirement.txt. So now we have all the data inside our Docker. Now we have all the libraries installed in our Docker. Now the next thing what we will do, we will expose 8080 port of our Docker. So here now we are mentioning that to interact with your Docker. So we are specifically telling our Docker is that receive inputs from this port, give us output from kind of this port. Okay, so this port is available for interaction with the world outside. So if I'm interacting with Docker container with the help of my PC, I have to route my request to this particular port. Okay, so I am specifically mentioned expose 8080 port from our Docker. So we are telling it to our Docker. Okay, and the final thing that we are doing inside our command line, inside the command prompt of our Docker, we are running like this: Python app.py. Okay, so this list is mean that it will create a complete kind of command for us. So Python app.py it will run, and if you remembered, Python app.py is our syntax to run our Flask API app. So when I created this Flask app.py, how I had run this particular thing, I simply had to do Python app.py. Okay, and if I run this particular thing inside my CMD, then my Flask API is running. So that is the only thing that I'm telling to my Docker. So when you complete all of these things, run this thing. Okay, Python app.py. So this command will run our Flask app. So this is a very small Docker file. Okay, Docker files can be complex, but for our project, this will work. Okay, so this is how we had created our Docker file. So I hope this particular thing is clear to you guys. Okay, so whatever thing that I have mentioned in my Docker file, I have explained it to you. Okay, what is the reason to include this? What is the reason to include this and all that we had mentioned. Okay, so this code is clear to you guys. At least you can relate which line is working what. Okay. All right, so this is our Docker file. Okay, so this is a simple Docker file that we had prepared. So our majority of work is done with the help of by preparing this Docker file. Now there is one more little thing that I had done apart from this Docker file, is to have this .docker ignore file. So have you heard about git ignore file? Any one of you? Git ignore. What is the function of git ignore? If you have used Git, then you must have encountered this git ignore. Okay, I'll tell you. So what does this Docker ignore file will do? So I am telling this particular Docker. So when you are building this Docker file now, so I'm telling it, we have this syntax now, copy whatever thing in your working directory to your app. Okay, so if suppose I am having lot of unnecessary files in my working directory, all of them will be copied to my app folder inside Docker. And what this will do, it will increase the size of my image. Okay, so whatever, if if there is any data that I'm not needed for deployment, I didn't want it to get there. Okay. So what is all the data that I didn't want? So here is all the things. Whatever the Python cache, okay, the cache of the Python, whatever the cache files, that if we had any cache files inside our folder, we don't want it to copy. If we have virtual environments in our folders, we don't want it to copy. Okay. If we have any git files, okay, if we have any version controls files or any git ignore files, we don't want it to copy to our Docker image. Any VS Code or any other thing, any other ID related temporary files also we don't want. Any environment variables also we don't want. And any large data sets, for example .log, .csv, .ipynb, we don't want anything to get copied inside your Docker image. So get predictions.ipynb and test.ipynb will not be there in your Docker image, because these files are just for our what do we say, that debugging purposes. We are seeing whether our model is working or not. Okay, these files are not required to keep our model working. Okay, so this is a Docker ignore file. Docker ignore file is used to specifically tell Docker what things to copy and what things didn't you want to copy. Okay, so like this is your Docker ignore. So we have introduced two new files, Docker file and Docker ignore file. Okay, now with the help of these two files, now we will build our image. Okay, so everyone is ready? Okay, until now the process is clear. Maybe you are not comfortable with syntax, but I am asking about the process, because syntax you will see and learn how to do this, how to do that. But the process, that why we are doing it, what is the purpose of doing it, that must be clear. Okay. Okay, so now we will create our Docker image. Okay, so for that particular thing, I have already set all the things there. So Dockerize our app. So first of all, you have to build your Docker image. So how to build your Docker image? The syntax is this: Docker build -t Flask Insurance API. So this is the name. This is the name of our image, Flask Insurance API. And how we are creating this Docker Insurance API? With the help of Docker file that is present in your current working directory. Okay, so this is the name of your Docker image, and how to build this image with the help of Docker file present in your current working directory. This dot represents current working directory. Okay, so I am just copying this thing. Okay, and I'll just rename our Flask image name, because the same name image is already there. Okay, so what I'll do, I'll open a command prompt. I can also do it below here, but again, I'll open a command prompt. So CMD is there. So this is a command prompt, and there are two ways. First of all, I have to go to that particular folder. So to go that particular folder, I have to write like this: cd desktop. Desktop is not there, I guess. Okay, so the shortcut is, whenever you feel something like this, the shortcut is go to that particular folder. So this is the folder in which we are working. No, this is not the folder. This is the folder. Okay, this is the folder in which we are working. We have one Docker file here, and all the model files and Docker ignore file is also there. Virtual environment file is also there. So what we will do, we will open CMD here, command prompt here. Okay. So this is our command prompt. So inside this GCP model, we had opened our kind of CMD. Now inside this, I'll write like this: Docker. Docker stands for your Docker command starts with your Docker. So Docker build. Okay, so we are building it. Okay, then I guess -t is there. Let me also confirm the syntax. Yes, -t. -t stands for your tags, that you can also give your tags here. Okay, we will discuss what do you mean by tag. Okay, so Docker build -t and then the name of your API. So suppose I'll give insurance hyphen flask hyphen API, insurance flask API. Okay, this is the name of our image, and after this colon you can also pass a tag. If you don't pass a tag here, the default tag is latest. Okay, so at present I'm not passing any tag here. And then on which folder, yeah, through which folder we have to make this image, Docker image, whatever the Docker file that is present in this current working directory, make this insurance flask API image using this. Okay, so this is our code. So this is our line to make our Docker image. So we have one Docker file, and with the help of this Docker file, we are creating a Docker image here. I just have to press enter. And now you can see that our Docker image is building. Load build context. Okay, error आ गया. Fail to resolve this unknown file mode. Okay. Why it is giving me an error? Unexpected. Flask Insurance API. Flask Insurance API. Same name था क्या पहले वाले का भी? Let me change name. Okay. Let me change its name. So again, I'll try. Yes, same name हो गया maybe. That's why. So insurance hyphen API. I'll just do like this. Okay. Docker build hyphen t insurance API dot. Let's build this. Again, same error. Fail to resolve archive tar unknown file mode. Okay. Let me see if there is an क्यों error आ सकता है. Let me see. Let's go into some debug mode. Okay. So app.py file is there. Okay, this is your app.py file. It is up and working. We have also tested that, so no fault in this. Did we have something here? Requirement.txt. Requirement.txt is also there. Okay. Virtual environment is also there. Insurance job lib polynomial object is also there. Did we have anything that we are missing? Same requirement.txt polynomial object adaptation Docker file. Docker file is also same. We'll copy this Docker file. I guess Docker file is absolutely same. We didn't change anything at all. Here, Control S. Okay. And suppose I'll run it here. Docker build. Yeah, what I'll do, I'll just copy this. Copy its syntax. So inside this terminal, okay, maybe there is a point. Yeah, I'm creating it outside virtual environment. Yes. See, in command prompt, what I am doing, I am creating my Docker image outside my virtual environment. Okay, so that might be an issue. So now I'm inside my virtual environment, and now what I'll do, I'll just rename it as insurance API, and now I'll build this. Now I think it will run. Okay, so now it is okay. Again, same error. Linux desktop, maybe some Linux version is. I'll just restart this Docker Hub. Okay, let me just restart this Docker Hub. Maybe there is some issue with Docker. Okay, Docker engine again start हो गया. Or if I see its error, okay. See, Docker is kind of working यहाँ पे. It is loading the definition from Docker file means it is reading our Docker file. Okay. Load metadata for Docker. Okay. So it is also reading this Python file. It has also read our Docker ignore file. Then transferring context. So this is the context it is transferring. And now it is building. Okay. And while building, it is giving me an error. Load build context. Transfer context 9 internal load build context fail to resolve archive.tar. Let me search this error first. Okay. I'll just copy this and I'll search it in browser. Try to execute a tar archive file during the build process, but encounters a unknown file mode. In your case, that the file permission are not properly set, or this can happen when are not preserved while extracting a tar archive. Okay, but there is no tar file. I have not set any permission. All the files are there and all the files are kind of ठीक है देखते हैं. The error it is giving me, it is something else regarding the permission. It is not related to Docker. Let's see one more time. Docker build insurance API dot. Same error. Load build context. So what files? Okay, insurance job lib is there, poly object is there, app.py is there, everything is same. There is no .tar file. Python 3.12, maybe they had some, but yesterday it is working fine. Okay. Let me also. Mhm. Okay, I'll go to this particular thing. Okay, this is our second setup. This is okay. Same Docker file, everything is same. So now what I'll do, I'll again open a terminal here. So let us experiment it here whether it is working here or not. So this is suppose our data, and again I have to activate the virtual environment. So .venv activated. Now I'll run this. Okay, मैं paste कर देता हूँ. Okay. And instead of this, I'll simply use insurance API, hit enter. Everything is same in those two folders. Why it is telling me that there is a tar file? And you can see it here. Your Docker image has, completed successfully. Okay. And like this. And you can also see your Docker image here also. So Flask insurance. And if I refresh it. Yes, the latest one is insurance API. So we had, we just have built this, okay, 613 MB. Now, okay, so this is our insurance API, right? But I don't know why it is giving me that error. Maybe something is there. Maybe some hidden file is there or what, that it is not able to extract or set file permissions. Maybe, but this is how you will make your Docker file. Again, I have to just look back there. What is that error that it is bothering? But you can see that all the files, all the data is same. Whatever that we had done there, it is there. Exactly same is there. Okay. Docker file is also same. Docker ignore is also same. Insurance and polynomial object is also same. Requirement.txt is also same. Okay. So all the data is here. Okay, okay, I'll try it one more time. Maybe I have to first log into that folder. Okay, so what I'll do, I'll just log in with my Docker. Docker auth is there, yes, Docker log is there. I don't know if it will work or not, but I'm just trying it. Authenticating with existing credentials, login succeeded. Okay, so you have to create an account also in your Docker and like this. And again, if I do something like this, our insurance API is already covered. Insurance one dot where we will do. Here is some file is there, internal load error. There is some file is there which is not, we are not able to do that. Okay, I'll explore this thing later on. Okay, but I guess you get the idea key how to do that. So again, no issues. We will work here. Okay, so we have our new file, our new Docker file is there. Okay, Docker image is there. So Docker image, we had built a Docker image. Okay, now the next thing is what we had planned. So with the help of this Docker image, what we will do, we will make a Docker container. Okay, so now we will make a Docker container. So how to make a Docker container? Again, we will go to this get prediction. To build a Docker image, you can build your Docker image like this. And to build a Docker container, you have to run this particular command. So what does this command is telling you? Okay, so first of all, let's understand this command. So you are telling that Docker to run a particular image. Which image? This is your image. Okay, whatever image that you had built, you are telling your Docker to run this particular image. So when you are running this particular image, what it will do? No. First we have to build. Yes, we build our container. Okay. So with the help of this Docker file, we have built our image. Now with this particular image, we are running a particular container. So we are telling our Docker to run a container with the help of this particular image. So this is our image. Okay. This is our image, a recipe. So we are telling a Docker to make a container out of this recipe. Okay. And what we are telling that key link your containers 8080 port with your host 8080 port. Okay, so what it is telling me that my PC's 8080 port is linked with your Docker's 8080 port. Okay, so if I'm sending any data to 8080 port, this 8080 port is got connected with your Docker. So what so the communication of your Docker with your PC. Okay, so communication of your Docker with your PC is it through 8080 port. Okay, so we are explicitly telling our Docker to particularly link this to this code to your host port. So this is your containers port, this is your host port. Okay, so we are linking this. Okay, so this is our command. Okay, this is our command. So what I'll do, I'll just copy this particular command. Okay, Docker run, and now I'll paste it here. Now see, I have to change this particular name. Its name is Flask Insurance API, but the image that we had made, its name is Insurance API. See, Insurance API. Okay, so we have to tell our Docker to run. Okay, Yuvraj, try Docker system prone for previous errors. Okay, I'll try. I'll try this. Okay. So yes, so Docker run -p. This is for port linking. Okay. Then I'll have to mention my image name. The image name is insurance API. So this is our image name, and I hit enter. Now at that particular time, your container is getting built. Okay, so this is, you are building your container for the first time. Okay, and your container is up and running. See, now you'll see the same thing. See, you again, you have you will see these three URLs. So this is your host URL. This is your host address on which you can able to get your output, and this is the URL of your inside your Docker. So if you want to get predictions inside your Docker, you have to use this URL. Okay, and you can see that your 8080 port is binded. Okay, both of the 8080 port are binded to each other. So whatever request that I'm sending to this will got received on this particular URL inside your Docker. Okay, so now uh, we got our URL. Okay, so now you can see that what we are doing, we are running our Flask application with the help of Docker. Here you can see that I have not written here Python space app.py. Okay, at present I'm running my Docker container, and while running my Docker container, it is running my app.py, and with this app.py I am getting this URL. Okay, so I hope this part makes sense to you what we are doing here. So we have, first of all, we have created a Docker image. Okay, after this Docker image, with the help of that particular Docker image, we have created a Docker container. Now with the help of that particular Docker container, what we are doing, we are running our application. So now our application is running inside Docker container, not on our not really on our PC. Okay, all right. So again, this is our URL. Now I'll copy this particular URL from here, and again I'll go to this get prediction thing. Okay. Now all I have to do is to just change this particular URL. Okay, and I guess URL is same, na? Because our ports are same. So this is your URL. Okay, and this is your home URL. After this home URL, you have to go to this predict, and in this predict, you have to pass this input data to your model. So when you pass this input data to your model will get you some output. And now you can see that if I pass this particular thing, I am getting this output. Now I am getting this output with the help of Docker, not on my PC locally. Okay, I am getting this output with the help of Docker. Okay, I hope you can able to relate what we are doing here. We have done the same thing before, but we had done it using Flask API server locally. Now we are doing the same thing using Docker. Okay. Are you guys able to understand? Is it getting too fast? Just let me know in chats. Okay, Keshav, I'll repeat. Which part you want me to repeat? Getting output with Docker? Okay, sure. So what I'll do, I'll again just close my Docker. So I have just exited from Docker. Now I had my Docker image. Now what I am doing, I'm running a Docker container. Okay, so how to run a Docker container? We have command for this. Okay, so if you see this get predictions notebook, inside this the get prediction notebook, we have this command. So this command will run your Docker container. Okay, Docker image creation part is also okay. Okay. So see, this is your Docker file. I guess Docker file is clear to all you now. I have explained you all this. How we are, why we are writing it all there. I guess Docker file is clear. Okay, I'll repeat it one more time. So yes, so we are making a Docker file. So Docker file is nothing but a set of processes that you will follow to create your Docker image. So I am telling you to create my image with the help of this Python version. Okay, set my working directory to this folder. So inside Docker container, set working directory to this particular folder. Now copy whatever data you are having in your current working folder. That means this folder inside this app folder. Okay, in my Docker container, I have to copy all of this inside this. Okay, then after doing this, we are installing our requirement.txt file. So inside Docker, inside this Python version. So because we have, first of all, we have installed this Python version. Now in this Python version, we are installing these requirements. Which requirements that we have mentioned in this particular file. Okay, like this. And after that, we are exposing 8080 port of our Docker to outside world. So whatever communication that we will do, we will make our communication with the help of this 8080 port. Okay. And finally, we are setting command to run our Docker like this, keep python app.py. So with the help of this command, we will able to run our app.py file. Okay, so that's why you are seeing the output when I'm running this Docker container. Because if I run this Docker container, then this command will run. Okay, all right. So this is my Docker file. With the help of Docker file, first I'll create a Docker image. How to create a Docker image? Again, you go to this, how to create a Docker image. This is the syntax to create your Docker image. So Docker build -t. This is the name of your uh, image. Okay. And space dot. Dot refers to your current working directory. Okay. In whatever directory you are, you have to mention this. If you are not in your current working directory, then you have to mention the folder through which you are able to, you are going to create your Docker file. Okay. So like this. So this is your Docker build syntax. Okay. With the help of this syntax, you are creating a Docker image. Which image? Suppose if I click this, you will see this insurance -API. So this image we had just built, insurance -API. Okay. And it is of 613 MB. This image is of. Okay. The insurance API, we had just built this API. Okay. So our images Docker file is made by renaming. Yes, you can rename a particular file. Yes, you can rename it. Okay, but they can't be modified. So if you want to modify a Docker file, they are kind of immutable. Once they are created, they are created. Okay. So if you want to avoid errors, always use different names and different tags. Okay. So that will, make your life much easier. Okay. All right. So from Docker image, if you want to build a container, okay. If you want to build a container, you can build your container with the help of this syntax. So this is your syntax to build your container. So Docker run -p. -p stands for port. You are binding your ports. Again, you can bind your volumes and all that. There are a lot other things in Docker also. Docker is also quite vast. Okay. Docker is mainly used for your DevOps purposes. Okay. So, but we are just covering it for your ML portion. So Docker run -p. -p binds your port. Which port it is binding? Your host machine's 8080 port is binded by your Docker's 8080 port. Okay, like this. And through which image we have to build our container. We have to build our container with the help of this image. So Docker will search for this image inside its repository, and as it finds that particular image, it will build a Docker container through this image. Okay. So this is your syntax to create your Docker container. Okay. Again, I'm copying this, and again, I'll just open this, and if you see it closely, I'll just expand it a little bit. Okay. And see, Docker build -t insurance API dot. This is your syntax to create your image, Docker image. And okay, I have to write it one more time. And Docker run -p 8080 like this. This is your syntax to run a particular image. So our image name is insurance API. So I'm running this particular image. So as I hit enter, this insurance API images will run. And as it is running, you can see that our app.py file, which is inside our Docker container, now it is running. And we can access that particular app.py file or that particular model with the help of this home URL on our host computer. So this is our host computer URL. So we can access with the help of this URL, we can access our model outside our Docker. Okay. And you can see that I'm accessing it here. Okay. This particular this IP address is same. Okay. And with the help of this predict, this curl, and this predict is your final endpoint. And on this predict, we are passing this input. And while taking this input, it will give us our output. So if I run this particular thing, you can see that I am getting this output. Now I am getting this output from my Docker container, not my app.py file in my PC. Okay. So we are getting this output from our Docker container. Okay. And same thing with the help of this request function. Okay. The IP address is same. Okay, name request is not defined. Import, we have to import this request first. And now you can see that again, we have this output. Okay, so all I am trying to say here, we are getting this output from a Docker container, not from our app.py file in our PC. So we had made a Docker container, and now if you export this Docker container to anyone, so suppose if I want to give this Docker container to you, and now if you run this particular Docker container, you will get the same output. You don't need to configure anything. You don't need to run requirement.txt. You don't need to set a virtual environment. You don't need to do anything. All you have to do is to run just 2 lines of codes. If you have the Docker image, you have to run the 2 lines of code. Which 2 lines? First line is Docker build, okay, to build your image, okay. And the next is Docker run, okay. So with the help of this, you can basically run your application, okay. And this only you have to do if you just have Docker file and all that, okay. But if I share you this particular image, so suppose if I share you this image, okay, if I directly shared you this image, you just need to run a single line. You just need to run this particular line, and your code and your application is up and running. Okay, irrespective you are running it on Ubuntu or Mac or Windows 10, Windows 11, any Python version, doesn't matter. Okay, if I shared you this particular image, you can also able to run it smoothly. Okay, so that is the power of Docker. Okay, so across various systems, you can easily deploy your models. Okay, you don't have to think about configurations. Okay, so about compatibility. So version compatibility issues are very well handled by Dockers. Okay, and that's why we are using it to deploy this particular thing in GCP. Okay. How to create Docker files. Address is same. How it is coming from Docker. Okay. So Mohit's question is, the address is same. The IP address is same. How we know that it is coming from Docker? Okay. So this IP address, you're talking about this now. Okay. So how I am knowing that it is coming from Docker is that because yes, because I'm running this particular thing, insurance API. Okay, so this is my Docker image. It has nothing to do with my original app.py file or anything. Okay, so I am running this particular image, and while running this image, I am getting this IP. So this IP is generated with the help of this image, not my app.py file that I'm running earlier. Okay, and if you see closely, when we are running it locally, this address is different. I guess it's 192 or something. It is something like this. And now it is different, 172.17. So this is the IP inside from your Docker. Okay, so with this, I'll know these data or these URLs are coming from inside my Docker. Okay. I hope, Mohit, I'm able to answer your question. Yes, Mohit, by binding. So see, we are doing now when we are running it. See, this minus p binds your ports. So 8080 is your host port. Okay, and this 8080 is your Docker port. So we are binding it. And also, while creating Docker file, we are explicitly telling our Docker to expose its 8080 port. Okay. All right. So this is your Docker part. We have successfully made a Docker image. We have successfully containerized it. And with the help of containers, we are successfully getting prediction from it. Okay. So this is our second part. Okay. First, we have covered how to create a Flask API, how to get predictions from it. Second, we have covered how to build a Docker, container out of that particular Flask API. And then we have also getting prediction from our Docker container. Okay. So a Docker container is also up and running. How you create Docker file? See, Docker file I have specifically written here. This is our Docker file. This is a Docker file. We have to write it. Okay. So for every project, your Docker file is different. What you have to achieve for a particular project, your Docker file might get changed. Okay. All right. Okay. So, okay, Docker part is there. Now comes our next part. So what is our next part? Next part is this. We have to push our Docker image to a Docker hub. Okay. So why we are doing it? Uh, Virtual environment name is before dot. Yes, I have included both things. Okay. So there are many type of virtual environments are there. So I have included all those options in git ignore file. Okay. Sorry, Docker ignore file. All right. So let's continue with this. So push the Docker image to Docker Hub. So now you will see that. Now if you see that, if I open this Docker Hub, okay. So now you can see that I have this insurance under hyphen API. Now this insurance hyphen API is in my PC. Okay. Now what I want to export it in my Docker Hub. So Docker Hub is similar to your GitHub. Okay. Docker Hub is similar to your GitHub. So what we are doing, we are pushing our image to a online repository. And what is the benefit of that? With the help of Docker Hub, we can easily import our Docker image into our GCP. So we don't have to manually, send our image to GCP. With the help of Docker Hub, it is easily integratable with your GCP. So what we are doing, we are sending this particular insurance API to our Docker Hub. Docker Hub is nothing but an online repository of various Docker images. Okay. Okay. See, Mohit, I'm not able to understand your question. Virtual environment name is before dot. In Docker ignore file, in which file you are telling me? Our virtual environment name is .venv. This is our virtual environment name. Okay. In which syntax? Here you are telling me? That dot for current directory for creating. For creating virtual environment. Okay. See, Python hyphen m, फिर venv, then your virtual environment name. So you can give it anything. Okay. All right. Okay, so what we are going to do, we are pushing our Docker image to our Docker hub. Okay, so how to do that? First, you have to make an account on Docker hub. Okay, so it is similar. So when you install this Docker desktop, it will ask you to log in. So then you have to log into this Docker desktop. So once you log in, you will have this a particular account. Okay, so for example, my account name is this GSCode 312. Okay, so with the help of this account, what I am able to do, I am able to upload my images to an online repository through which I am able to access my images anywhere. Okay, so what we are trying to do, first we will log in through our Docker. Okay, so the syntax is Docker login. Okay, so I have already logged in through my Docker, so it will not ask credentials. Okay, ask me for any credentials, but for you, if you are doing it for first time, it will ask you for credentials. Okay, so okay, so this is it. So first of all, I'll just end my Docker, stop my Docker container. So we have stopped our Docker container. Now what I will do, I'll just log in through Docker. Okay, so authenticating with existing credentials. For you, it will ask for your user ID and password here. Okay, and because I had already logged in through that, so it is not asking me. Okay, so first of all, you have to log in. Okay, now I'm successfully logged into that. Then what I'll have to do, then I'll have to use this particular syntax. Now, what this syntax is doing, I'll explain it. Okay. See, so Docker tag. Okay, so we are tagging it. What? This is your API. This is the image that you had in your PC. Okay, so the image that we had created is this. Okay, now we are exporting this particular thing online. Where we are exposing it, where we are pushing it, we are pushing it to this particular uh, address. So your address is whatever your username. Username means your Docker username. For example, in my case, it is gs3312, something like this. Okay, then this is the name of your image. Okay, so suppose again यहाँ पर I'll give this image. Okay, then you can also pass a tag here. For example, latest or version 1, version 2, you can pass anything. Okay, so this is your tag thing. So with the help of this syntax, as you have logged into your account, you can push this particular image to an online repository. Okay, so this is just for tagging. We are just creating a tag here, and after creating a tag, then we will push it. Okay, so first we will create a tag. So I'll just copy this particular line and I'll just edit this. So copy this, and again, this is our this, and I'll paste it here. Up see Docker tag. Our if I go here, our image name is insurance API. Okay, and I have to type my username here. So suppose username is GSCode 312. Okay, and now I have to type what name I want to give it to it to insurance API, and here I'll give tag latest. Okay, so this is my syntax. Okay, so Docker tag, we are just tagging it. Okay, so now we had successfully tagged that particular image. Okay, now whatever tag that we have created here, now we are pushing your Docker image into this particular tag. So your syntax is this Docker push. Okay, so we are pushing it. GS code 312 Flask insurance API. So our name is insurance API and tag is latest. So we are pushing this particular image to our Docker repo. So as we run it, now you can see that our Docker image, which is locally stored, is pushing online. Okay, so now we have successfully uploaded our image online into Docker Hub. Okay, I'll repeat it one more time, but just see this. So now you can see that in my hub part, so this is my username. So in my hub part, I am able to see this insurance API. Okay, and we had just pushed it 10 seconds ago, and its size is 143 MB. Okay, and now we can use this particular image to deploy our model into Google Cloud, GCP. Okay, so this is how we had made our Docker image, and we pushed our Docker image into an online repository so that we can use it anywhere, be it GCP, Azure, AWS. You can use it anywhere now with the help of Docker Hub. Okay, all right, so Soumya says, can you repeat last two commands? Sure. See, the commands are like this. Okay, I guess you understand up till here. Okay, we are getting predictions from our Docker model. Okay, now after that, what we are doing, we are logging in to our Docker Hub account. Okay, because if you want to upload it anywhere online, first you have to make an account. Okay, so you have to make a Docker Hub account. Okay, so Docker Hub account. So you have to log in using this particular account. So Docker login, and it will ask you for your user ID and password a single time, only one time for a particular folder, and after that, you can able to log in. Okay, so first of all, we have to log in. After that, what we are doing, we are tagging a Docker image. Tagging a Docker image means you are creating some kind of, for this particular image, this is our tag. Okay, this is our tag means how to say that, we are creating an empty structure. Okay, with this name we want to push our Docker image to this particular name. Okay, so basically we have our Flask insurance API, so we are tagging it using this. Okay, so that when we push this particular image to your Docker Hub, it will push seamlessly. So we are tagging it with a certain format. Okay, so this is our base image name, and we are tagging it using this particular thing. Okay, and you have noticed that I have also tagged it using latest. Okay, so this is your command. This is used to tag, and you can also see this in my local. This is your insurance API, which we had created earlier, and yes, this is your, again, a tagged copy of your kind of image, insurance API GS code 312. So we have created this. So this particular code that I had mentioned here, this Docker tag, this particular code, what it is doing, it is creating this particular tag from this particular image. Okay, so we are not able to change this image, but we had renamed this, or we have retagged our image like this. Why we have retagged our image like this? Because it is very convenient now to export this image, because this image contains this, the name of that image follows a particular pattern. Okay, and that pattern is suitable for pushing it to Docker Hub. Okay, so as we have tagged our image like this, we simply have to push our image this. So whatever image that we are having inside our Docker desktop, we are pushing it into our Docker Hub. Okay, so first of all, we have retagged our image, okay, to make it suitable for Docker push, and then we pushed our retagged image using Docker push command. So what it will do, it will send your data to your Docker Hub account. Okay, send your Docker image to your Docker Hub account, and you can able to see this. Okay, so from images, and you go to this hub part, and if you want to see it online, you can also select, for example, okay, this is your browser, this is this, and if I said view in hub, so this option is nothing but view in hub. Okay, so this is your online repository, and in online repository, this is your Docker image. Okay, all right. So this is your Docker image. GS code 312 insurance API latest. See, we have exactly named our model like this. Okay. So this is your pushed Docker image. Okay. So now our Docker image is pushed online into Docker Hub, and now we are ready to deploy this particular Docker image into Google Cloud. All right. Okay. So let's move to Google Cloud. Okay. So now comes deploy your model in GCP. Okay. So now, first of all, I'll just give you a brief introduction. What is GCP, how it is doing. So first of all, GCP is not free. Okay. So those of you who are, planning to deploy your models on GCP and want to share your projects, don't use GCP because GCP is used for external deployment. Okay. And it is not. Okay. First of all, you have to log in to GCP with the credit card, and initially you will get free credits. Okay. So 2,000 rupees, 3,000 rupees, something you'll get. Okay. For 90 days. So yes, after that particular free credit got expired, you are again charged on your credit card. So if you don't know about Google Cloud, okay, suppose if you place your model and use some services, and all the services are chargeable in GCP, and you forget to switch off that particular services, and your resources are getting consumed continuously, then it will generate, a good part of revenue to your credit card. Okay, a good amount of bill got generated for your credit card. So don't do it if you don't understand it. Okay, if you want to showcase your project, there are plenty of free cloud platforms are there where you can deploy your projects. Okay, but GCP is for your production level deployment. Okay, so all the major companies are using AWS, Azure, and GCP. Okay, so most probably when you'll got into a company, there you'll use these cloud. Okay, all right. So when you log into your GCP, so I'll just, whether apart from doing, I'll show you what is GCP. So I'll just go to my GCP account. Okay. So this is your GCP. Okay. And there are various services that, or various things that you can do it. Mohit, Azure and AWS are also not free. Okay. All of them are chargeable. They'll give you free credits. Okay. But after your free credits got expired, they are chargeable. Okay. So suppose I'll go to this console. So this console is nothing but your dashboard. Okay. So this is your okay console, and here it will tell you okay, how many credits you are there, you got there, and how many you have used or something like this. Okay. And there are various products that you can use. Okay, there are various models, generative AI models, BigQuery models. There are a lot of things that you can do. Okay, so like this. Okay, and these three dots here, you can have various services that you can use. Okay, in Google Cloud, for example, APIs and services. So suppose if I want to deploy outside this Docker, if I want to deploy a particular, with the help of Flask API something, then I can use this. Or if I suppose want to use various other services from your Google Cloud, then I can use this API and services. Okay, so enable API and services. So if you go to this particular option, you will have a lot of APIs: Cloud Run API, Artifact Registry API, Cloud Build API. Okay, there are various things. Okay, now at present in this particular experiment, what we will do, we will be using this Cloud Build API. Okay, we will be using this Cloud Build API, and with this Cloud Build API, Artifact Registry API and Cloud Run API is also will also be running. Okay, so we will be using these APIs. So what I had done, first of all, I have to enable this Cloud Build API. So suppose if I go to this Cloud Build API inside this Google Cloud, okay, then I have to enable this particular API. Okay, so like this. See, here status is enabled, so I have to enable it. Okay, and there are a lot of version and a lot of settings that you can you can tweak. Okay, but I have just didn't tweak anything. Okay, all the things are default. Okay, so this is your cloud build API, which is our main API that we will be using to deploy our model. Okay, create and manages build on Google Cloud Platform. Okay, okay. See, I am showcasing you the click around way, ki how to use Google Cloud with the help of clicks and UI. Okay, but in my Jupyter notebook, I have explained all the things using command line prompt. So you don't have to go to this Google Cloud and do all the things. All the things can be able to we can do with the help of command line also. Okay, and that is much more convenient and much more automated way. Okay, so this is your API services. Okay, apart from this API services, this is your billing part. So in this billing part, you will see what are the services that are charging you, how much amount that is left, and all that things. Okay, I am an admin. This is referred to all the permissions. Okay, whether you are allowed to do a certain thing, whether you are allowed to access a particular app or not, all the permissions and all that are setted. We set using this I am an admin. Okay, the service accounts are there. Okay, so the settings and privacy and security. Okay, roles. Okay, all the things are managed by this I am role. Okay, this Vertex AI, this is their most kind of, you say, well-known at present product. So this will contain all your, this is an AI studio, and it will contain all your kind of models, chat model, vision models. Okay, all the things are there. You can train your model there. You can fine tune your model there. Okay, so all the things are there in this Vertex AI. Okay, so Vertex AI is this. Okay, so when you are building something with the help of Google Cloud, you will go with Vertex AI. At present, we are not building anything. We have already built in our laptop or on our PCs. Now we are deploying it on GCP. Okay, but when you want to build something, Vertex AI is where you will go. Okay. Compute engine refers to how much compute or how much computation power you require for something. Okay, so again it depends on the specific purpose that you are using, for which you are using your Google Cloud. Kubernetes engine is nothing but we can also deploy our model with the help of Kubernetes engine, but that will require far more kind of settings and all that. So we opted for a very simple way with Docker deployment, and you'll see how easily it will get deployed. Okay, BigQuery part is again your SQL equivalent of your Google. Okay, so Big Cloud is your online RDBMS platform where you can query, you can store your data. Okay, you can do all your things. Okay, SQL transactions. Okay, monitoring. Okay, BI engines and all that. Okay, BigQuery Studio. Okay, so BigQuery is also there. So we are using this Cloud Run thing. Okay, so I'll go to this Cloud Run. Okay, and we will be using this. So I had already, uh, 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 exported some Docker images there. Okay, so this is our latest Flask Insurance API, which is running. This Sentiment API things are not, I'm not able to run it because of some memory issues and all that, because these images are quite heavy. Okay, okay, but their Docker containers are running. So some tweaks here and there, and they'll also start working in Google Cloud also. Okay, so this Flask Insurance API. Okay, so this is my container. Okay, so you can either deploy your things with the help of command line interface from your PC, or you can also deploy it using here. Okay, so first of all, I'll showcase you how you can deploy your what to say Google Hub image with the help of Cloud Run. Okay, so what I had done up till now, I just go to my home page. So this is my home page. I'll just go to this home page. So this is our home page. Okay, so when you are at particular home page, Google Cloud asks you to create a project. Okay, so how to create a project? So if you just click here, you can create a new project. So just one thing to let you know, Google only allows you to make 25 projects. Okay, in free tier. Okay, so I had already made these 3 projects. At present, I'm in this review test. Okay, so this is my review test. project. Inside this project, okay, inside this project, what you have to do, you have to go to Cloud Run. Okay, Cloud Run. So this is your serverless for containerized applications. Now you see that we had our applications containerized with the help of Docker. And now why I have chosen this serverless? Because for our type of application for demonstration purposes, it will cost less. Okay, I have to tweak some less permissions. Okay, because it only allow resources when I'm querying it. If I'm not querying it, it will not charging me anything. Okay, so that's why I have chosen this Cloud Run. Okay, so inside this Cloud Run, suppose you'll get this particular interface. Now what you have to do, you have to do this, you have to go to this particular button, deploy container. Okay, because you have already containerized your application. Now you have to just deploy this particular container. Okay, again, service or job, you want to select service. Each service has a unique endpoint and auto scales deployed code. Okay, so we selected service. Okay, now see what it is telling us. It is telling us from where you want to deploy your model. Either from artifact registry. Artifact registry is your Google's default registry, as your Docker Hub is there. So there is artifact registry is also there. Okay, or here is Docker Hub is also selected. Okay, so we have our image already pushed to our Docker Hub, so we have selected this. You can also do it with GitHub also. Okay, so we have already pushed to Docker Hub. Okay, now here what we have to enter here, we have to enter our Docker image URL. Which URL? So again, if I go to this Docker Hub and if I go to this view in Hub, or simply I'll go to this. This is my URL info, GS code 312 insurance-APIs. I'll just copy this. Okay. And to complete this URL, okay, this is your Docker Hub and docker.io. Okay, here it is not coming, URL. Okay, I had mentioned it here. Let me see. So your URL will be, see, docker.io, then your complete URL. Okay. So again, if I go to this and Cloud Run, here I have to mention URL. So again, I'll just copy this for the sake कि हमारा error ना आए. So image is this. Docker.io and like this. And here we will just use GS code 312, then again slash insurance hyphen API. Okay, I guess it is correct. Okay. Okay, select is from artifact or container registry. We don't want that because we are already doing it with the help of Docker. Okay, so I'll just copy this and paste it here. So GS code 312 insurance API. This is our image URL. So this is our Docker Hub URL. So we are directly connecting our GCP with our Docker Hub from here. Okay, and here you are specifying your image name. So what image name we are trying to give? Insurance hyphen GCP hyphen version 1. So this is the name of our image, insurance GCP version 1. Okay. Then it is telling us which region you want to select. Okay, which region you want to host your data. So there are various regions, and according to that you have various pricings. So tier 1 pricing, tier 2 pricing is there. So I am just going with my default. Okay, so you can also select various regions here. Okay, there are Asia Pacific is also, okay, I guess India will be there. So if you want, if suppose if you're working in a company and if there is something like this, your data must be remain in a particular geographical location, because there are some foundations. Okay. For example, WhatsApp, the data of Indians from WhatsApp must be stored in India. Suppose if government says something like this, then if WhatsApp is using GCP, Azure, or AWS, they have to make sure that their data centers must be in India, so that whatever data that their applications are processing or sending must be stored in India. Okay. So for them, these things must be mandatory. Okay. They are storing in Delhi, they are storing it in Mumbai. Okay. These things are mandatory. But for us, this kind of uh, restriction is not there. So I just go with default thing. Okay, so there is question from Mohit. We can give any service name. Yes, Mohit, you can give any service name, but that must be unique. Okay, service name must not be, repetitive. Okay, must be unique. So insurance GCP version 1. Okay, then endpoint is this. Now see, what do you mean by endpoint? So you have seen that when we are getting predictions. Okay, so this is our URL through which we are getting predictions from our Docker or from our, locally. So now this is our URL up to 8080. So whatever thing that we are pasting it here from HTTP, then colon, then slash आपका 127.0.0.1 8080. So that particular URL refers to this URL now for GCP. So for GCP, it will be this URL. So this is the endpoint URL of your GCP. So we can use this particular URL in place of this particular URL. Okay. And after this URL, if we enter this predict and then we hit, then again, our model will redirect to GCP and get our prediction back from GCP. Okay. So that is the endpoint for GCP. So this is your endpoint URL. Okay. Just keep this in mind. Then here is this authentication part. Allow unauthenticated invocations and require authentication. Okay. So if you say that this require authentication, then you have to again pass some certain rules. For example, you have to set some firewalls. You have to set some load balancers. Okay. To check if a person is querying to your URL, whether that person is authorized or not. So all of these things comes under firewall and load balancers. Okay. So at present, I am doing like this: allow unauthenticated invocations. Unauthenticated invocation means you have hosted, allowed everyone to access your model. So suppose if I, share this particular URL with you guys, you can also able to access my model. Okay. So there is no restriction. So at present, I'm setting it to this: allow unauthenticated invocations. Okay. Next, CPU allocations and pricing. So again, CPU only allocate during request processing. Okay, you have to set this permissions carefully, because if I set it like this, then what will happen? It will charge me with the help of this. Okay, first 240,000 vCPU seconds per month are free. Apart from that, it will be charging me. So again, I have to set it like this: key only allocate CPU if I am querying it. Okay. Mohit is asking, any free platform? Yes, Mohit, you can try Hugging Face. Hugging Face is a free platform, but that many functionalities are not there on Hugging Face. Okay. Again, Hugging Face is also free and paid. So there are certain things that are free, certain things that are paid. Okay. So like this. Okay. And again, so again, ingress control is something like this: allow traffic from your project shared VPC, virtual private connections, and server controls parameters. Traffic from another Cloud Run service must be routed through VPC. Okay. So whether you want to, because if you are working in a company, then if they are using any VPNs and all that, they are using any particular networks, then you have to set that particular network here. At present, default is there all, means anyone from internet can access your applications. Okay. So first of all, this. Okay. Next, there are container settings. In container settings, see, this is the default port for your GCP. That's why I have to set 8080 there. Okay. So GCP uses 8080 as your default port. Okay. And because of that, I also made it similar with my Flask API and with my Docker. Okay. So this is your container port. And then this is your resources. So Google Cloud default allocates 512 MB for every container. if your container exceeds this particular amount, then it will stop. Okay. But you can also set different storage units here. Okay. 1 GB, 4 GB, 8 GB, something like this. Okay. And according to your storage, you will get charged. Okay. So like this. And you can also select GPUs. And if you select GPUs, then also charging is there. So for every service, there are charges in GCP. Okay. So these are some container settings. Okay. And after doing all this, if I click here, create. Okay. If I click here, create, then my uh, that particular what to say, Google Docker image is getting built. So now you can see that this is my insurance GCP version 1, and this is the tag given by GCP itself. Okay. Now it is getting created, and now you can see that it is up and running now. So this service is up and running. Okay. And now if I, and you can see the URL also, this is our URL. So we can access our particular this um, what do you say, application with the help of this URL. So I'm copying this particular URL. Okay. And again, I'm going to this get prediction. Okay. Now what I'm doing, I'm testing this particular thing. So here is my previous URL. Okay. Now I'm pasting it, my latest URL. So Control V, paste. So this is our insurance GCP version 1. Okay. US Central region, that is hosted in US Central region. Okay. Run.app. So this is our home URL. After this, I'm setting it predict. Okay. So this is the path on which I'm getting my predictions. Okay. And again, this is our normal input data. Anna? We are testing it using curl command. And if I run it, now you can see that I'm getting my answer. And this answer is coming from GCP itself. It is not coming from my computer, not from my Docker. It is coming from GCP. Okay. So this is how you can deploy your Dockerized containers into GCP and get predictions from GCP. Okay. Again, if I change this URL here, okay, up till here, okay, and run this, again, you'll see that we get our prediction like this. So now we are getting this prediction from GCP, not from, our, what we say, PC or any Docker container. And if I paste this particular code into chat and even if you run it also, you'll also get this same prediction. Okay. So what I'll do, I'll just share this code with you guys. Okay. And if you run this particular code, then you will also get the same prediction. Okay. Just try this thing. Okay. So like this is how you can deploy your applications to GCP and you get your kind of predictions. So there are a lot of configurations that we have, successfully bypassed because we have used Docker containers. And if we don't use Docker containers, then we have to set up many things. So with the help of Docker containers, the process is very smooth. Okay. And in this particular notebook that I have also shared with you, here I have mentioned how to perform all the same things using your CMD. Okay, so if you run these particular commands, then again, you'll get your app up and running. Okay, you don't need to go to this Google platform there. Okay, so like this. Okay, now, so that's it. That's it. That's all the topic that we are going to cover today. So now I'm opening for questions. Okay, so if any one of you has any questions, then we can take it now. Yes, Mohit, you can add this link to a website also. Anywhere you can deploy this link. Okay. So now if your company makes different applications, for example, mobile app, a website, a desktop app, anywhere, so you can use this particular API to deploy your model, to get your model functionalities to that particular softwares. Is Hugging Face similar to this? No, every cloud is a little bit different from each other. Okay, Hugging Face actually well known for its LLM parts, because there are a lot of LLM models are hosted there, and you can also deploy those LLM models there. Okay, so actually it is basically known for that. Okay, whatever the things now that we are doing here, making serverless applications and user authentication and all that. These things are there, but they are not very feature rich. Okay, so if you want to deploy a production grade service, at present in market there are only three players, major players: AWS, Azure, and GCP. Locally access GCP. I'm not able to understand your question. Locally access GCP means? Repeat your question, Mohit. I'm not able to understand that. Okay, Jupyter. Okay, so code is there. See, Google Cloud Run. Okay, so code is mentioned there. So first of all, what you have to do, you have to go to your Google console. Okay, then you have to create a new project that I have already shown you. Then you have to start your billing. Okay, you have to enable billing from your Google Cloud account. After you had done that, what you have to do, you have to install this Google Cloud SDK. So if you go to this particular link, so suppose I go to this particular link. So here it is there, how to install it on Windows. Okay, so Google Cloud CLI installer. So it is a nice, okay, simple tool which you have to install before you use Google Cloud in your terminal. So this you have to download and install. Okay. After doing this, you have to go to your terminal and type this command: gcloud auth login. Then it will ask for your username and password. Give it your username and password and you are good to go. Okay, so your gcloud is, you can able to gcloud in your terminal. Okay, then what you have to do, you have to set your project ID. Okay, you have to create you had created your new project, then you have to set your project ID. So here you are setting your project ID. Okay, where you can see your project ID. So see, if you go to this gcloud, for example this one. Okay, and if I go to this, see, this is our project and this is our project ID, review test 437417. So we have to set this project ID there. Okay, we are doing working this particular project. Okay, you have to select that particular thing. Okay, then what you have to do, you have to enable Google Cloud Run API. So I have shown you na ki you have to first go to Google Cloud API and then you have to enable it. So you can also enable it using this. Okay, you can also enable it using this. So this will enable your Google Cloud Run API basically. And after this is your main command. Okay, so this command will deploy your model. So gcloud run and deploy. This is the name of your service. So whatever service name that we are setting, this is your service name. Okay, then this is your URL. This is your Docker Hub URL that you have to enter there, through which you are able to create. You will able to create your model. Then platform managed means GCP will manage all the server requirements, all the RAM, all the CPUs and all that. It is managed by GCP. We are not managing it. Okay, so this means ki if you had many number of requests, then it will automatically scales your resources. Okay, region is US Central. Okay, again you can enter any region. and allow is unauthenticated, means anyone is able to access your application. Okay, so this is your full command. Then if you use this command in your terminal, it automatically starts your model creation in GCP. Okay, after that, if that particular thing runs successfully, it will give you a particular URL like this. It will give you a URL like this. Okay, and then you can use this particular URL to get your predictions. Okay, so above is the process how you can use it inside your terminal, and here I have also shown you how you can use it in your Google Console, Google Cloud Console. Okay, all right. So I guess if you guys don't have any questions, then we can wrap it up for today. Okay, so I'll just wait for 1 or 2 minutes. If anyone has any questions, then we can take. Otherwise, we'll wrap it up. So GitHub is different, Docker is different. GitHub versus Docker, both of them are different. They are solving different problems. All right then. Okay. I hope you learned something new today. There are a lot of topics that we had to go through, and there are a lot of things that you have to digest. Okay. So just take your time. Okay. All the resources are there on Google Drive. Okay. And recording will be shared to you. Then you can also watch recording many times. Okay. But these concepts are, comes handy when you go in a company. Okay, or when you appear in an interview. Okay, so if an interviewer know that, okay, this is how you can deploy things, these are the topics that you already know, so it gives an impression that, okay, you are working professionally. Okay, you are not here just by looking some YouTube videos and just running some Jupyter notebooks and getting your predictions. Okay, so these are some professional level stuff, that how you can deploy your applications professionally. Okay, using Docker, using in a cloud. Okay, so these all things, these little things impact your chances. Okay, so try to learn these topics. Okay, they'll definitely help you out in your future journey. Okay, so with this we are wrapping it up for today. Okay, thank you everybody for your time. Okay,
Hit the like button, subscribe to our channel, and tell us in the comments below what topic we should dive into.